I request them to please take their seats on the dais. वरदे वीणा वादनी वरदे कास अंग उर के बंधन पर जननी ज्योतिर्मय निर्झर कलुष भेदतम हर प्रकाश भर जगमग जग कर दे वरदे वीणा वादनी वरदे
शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर मर्म में मेरे कृपा कर मर्म में मेरे कृपा कर आप आए हंस पर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर माँ करूँ तुमको नमन मुझको शरण में लीजिए माँ करूँ तुमको नमन मुझको शरण में लीजिए हे दयामयी देवी सिंधु हे दयामयी देवी सिंधु बुद्धि हमको दीजिए शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर नेह पाकर आपका वाणी अमर हो जाएगी नेह पाकर आपका वाणी अमर हो जाएगी ज्ञान मिल जाए हृदय की ज्ञान मिल जाए हृदय की कालिमा धुल जाएगी शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर मर्म में मेरे कृपा कर मर्म में मेरे कृपा कर आप आए हंस पर शारदे वरदे ये मेरी बुद्धि हो जाए प्रखर
Namaskar. On behalf of IIS Deemed to be University, I welcome you all to the inaugural ceremony of the 8th Rajasthan Science Congress. The focus of the Congress this time is on sustainable formulas that can help in interactions of humanity with the environment for the overall health of the planet. With this zeal and thought in mind, let us begin with the Congress on Science and Technology for Sustainable Development. Before we proceed further, as part of our university's tradition, we begin by invoking the blessings of the Almighty. May I request Dr. Ashok Gupta, Honorable Chancellor, Ms. Mugdha Sinha, Secretary, Department of Science and Technology, Rajasthan, and Dr. Sandeep Sancheti, Provost, Marwadi University, Rajkot, to please come forward and light the lamp. I also request Professor T.N. Mathur, Honorable Vice Chancellor, to please come forward as well. May I now request all the other dignitaries on the dais to please join them.
सद्गमय नमो ज्योतिर्गमय मृत्योर्मा अमृतं गमय असतो मा 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 सद्गमय नमो ज्योतिर्गमय।
Thank you all. मन में उमंग तथा नेत्रों में भरकर खुशहाली के प्रति हाथों में पौधे लेकर कर रहे हैं हम आपका अभिनंदन. May I request our Honorable Chancellor Dr. Ashok Gupta to bid a warm welcome to the chief guest of the event, Ms. Mugdha Sinha. Thank you, sir. May I request Dr. Ashok Gupta, Honorable Chancellor, IIS Dean to the University, to please deliver the welcome address.
Namaskar. The chief guest of this 8th Rajasthan Science Congress inaugural ceremony, Ms. Mugdha Sinha, Secretary, Department of Science and Technology, Government of Rajasthan, Ms. Tarun Kumar Jain, Editor, Vaigyanik Drishtikon, and Convener, Rajasthan State Rajasthan Science Congress, Professor Y.K. Vijay, Director, 6th and Chairman, Rajasthan Science Congress, Professor T.N. Mathur, Vice Chancellor, IIS Deemed to University, Professor Raki Gupta, Rector and Registrar, as Dean to the University and Vice Chairman, Rajasthan Science Congress. Professor K. Sharma, Advisor, as Dean to the University and Vice Chairman, Rajasthan Science Congress. Dr. Sri Moi Chatterjee, Organizing Secretary, Rajasthan Science Congress. It gives me immense pleasure to welcome you all to the 8th Rajasthan Science Congress, organized over 3 days from 20th to 22nd October 2021. This year's Rajasthan Science Congress focuses on science and technology for sustainable development. It is being hosted by IS University, which is among the pioneers in Rajasthan in imparting high quality education to women in different streams. It is known for excellence in delivering value-based education to students and encourage them to think innovatively in different walks of life. It particularly focuses on preparing students to become world-ready citizens who are capable of undertaking any professional and social challenges with an educated and empowered mind. Sustainability has become a byword in these days that look to better and cleaner methods for resource utilization. Scientific research and technology is paving the way towards a brighter, stronger future along integrated lines of thought, innovation, and action. I'm sure this future, if attained through sustainable development, will provide insights into most aspects of the human world, spanning domains of business and technology, as well as the environment and social sciences. To this end, the Rajasthan Science Congress has long been working towards a common goal, that is, of providing the diverse scientific community with a common platform for interaction and exchange. It is only through such mediums as this one that we may share and grow together and fulfill the common purpose of collective social development. We need to focus on the solutions which we know exist or have the potential to be developed, and this is where technology along with behavioral change can help us reboot the health of our nature and planet. In light of these efforts, we are pleased to collaborate with Vaigyanik Dristikon Society for organizing this event to explore the ways to move towards more sustainable and greener society. We have around 20 invited speakers and over 200 participants from all over the country. I'm confident that the technical sessions by eminent speakers, model exhibition by DRDO and other organizations, and poster presentations would cover most of the aspects pertaining to science and sustainability. I'm sure these 3 days of knowledge sharing will expand our vision on various aspects related to science, technology, and sustainable development. With these words, I once again extend my heartiest greetings to all of you and greet the exhibitors also who have come all the way from different government departments to present to the students various programs and activities of these organizations. I'm grateful to Ms. Mukta Sinha for having accepted and acceded to be our chief guest and for all the support she has extended in organizing this Congress. With these words, I welcome you again.
Thank you, sir. May I now request Professor T.N. Mathur, Honorable Vice Chancellor, IIS Dean to the University, to please say a few words. May I request Dr. Sandeep Sancheti to please take his seat on the dais. May I request Honorable Vice Chancellor Professor T.N. Marshall to formally welcome the keynote speaker Dr. Sandeep Sancheti, Provost, Marwari University, Rajkot. Thank you, sir.
Respected dignitaries on the dais, the faculty members, deans of the university, and staff, on behalf of the IAS family, I welcome all esteemed members and speakers who are gathered here for this 8th Rajasthan Science Conference. It is a commendable attempt by the RSCA to organize this Congress and provide a platform to researchers, academicians, and scholars to share their ideas and indulge in scientific discussions and constructive dialogues. In today's times, when the science has stretched itself to the world of economics, society, and environment, its extended involvement and role also enabled scientists to create potential resources to realize the aim of sustainable development for Earth. Organized with this vision, this event involves experts from various fields who will make possible to exchange of diverse ideas under sessions planned during this Congress and successfully bring together members from the scientific community to find solutions to the existing challenges in order to provide a comfortable life to common citizens. I hope this Science Congress would certainly induce innovative ideas among the candidates. I wish the 8th Rajasthan Congress a very successful and meaningful participation. Jai Hind.
Thank you, sir. I now invite Sri Tarun Kumar Jain, Editor Vaigyanik Drishtikon and convener Rajasthan Science Congress, to talk about the scientific viewpoint of the event.
आदरणीय मंच पर बैठे हुए विद्वान और सामने बैठे हुए विद्वानों को प्रणाम करते हुए मैं 5 मिनट में अपनी बात यूँ शुरू करना चाहता हूँ कि जो राजस्थान साइंस कांग्रेस की शुरुआत हुई तो राजस्थान के बहुत बड़े बड़े वैज्ञानिकों के दिल में एक इच्छा थी और वो इच्छा उन्होंने जब मुझे कहा कि ऐसा कुछ राजस्थान में होना चाहिए, आप साइंस कम्युनिकेटर हैं और आप पूरे देश में साइंस की एक्टिविटीज़ को कवर कर रहे हैं, घूमते हैं, आते हैं, जाते हैं, तो हम चाहते हैं कि राजस्थान में भी ऐसा कोई एक प्लेटफॉर्म मिल जाए हमारे युवा वैज्ञानिकों के लिए, तो वो बहुत अच्छा एक एक्टिविटी हो जाएगी। और इसको अभी तक हम लोग सारे मिलकर इनिशिएट नहीं कर पाए हैं, तो ये आपके यंगस्टर्स की टीम के माध्यम से होगा तो ज़्यादा अच्छा रहेगा। ये जब बात और लोगों से भी चर्चा हुई तो बहुत सारे विद्वानों ने इसके लिए बहुत ही अच्छा पॉजिटिव रुख दिखाया और धीरे धीरे करके ये शुरुआत हो गई। मैं यहाँ बहुत बहुत आभारी हूँ, संकेती साहब बैठे हुए हैं मंच पर, वो स्टार्टिंग के दिनों में उन्होंने बहुत बूस्ट दिया हमें और तीसरा राजस्थान साइंस कांग्रेस का आयोजन अपनी लीडरशिप में मणिपाल यूनिवर्सिटी में कराया। और बल्कि मैं स्पष्ट रूप से कहूँ तो ये मान सकते हैं हम कि 1, 2, 3 यानी 1, 2, 3 के बाद ही दौड़ना शुरू होता है, तो संचेती साहब के इन्वॉल्व होने के बाद ही ये दौड़ना शुरू हुआ। और ये तीसरे जो आयोजन के बाद हम थोड़े सिस्टमेटिक हो गए, सारी चीज़ें उन्होंने हमें समझाई और ये बहुत अच्छे से अब चलने लगा है। अब यूनिवर्सिटी आ रही हैं और विज्ञान को आगे बढ़ाने के लिए अपने एफर्ट्स जो हमें दिखा रही हैं सारे देश को या प्रदेश को। एक मेरा और बताने की यहाँ बात है कि इसका जो उद्घाटन, जो शुभारंभ हुआ था 2012 में, डॉक्टर अनिल काकोडकर साहब ने किया था और वो इसका अनाउंसमेंट करने के लिए जयपुर आए थे। उन्हें ये बात इतनी अच्छी इसलिए लगी कि राजस्थान जैसे स्टेट में भी अगर लोग आगे आते हैं और अगर विज्ञान को बढ़ावा देना चाहते हैं, युवाओं को आगे लाना चाहते हैं, तो मैं ज़रूर आऊँगा। और वो आए और उन्होंने इसका जो मतलब आरंभिक हमारा संविधान बना हुआ था उसको रिलीज़ भी किया। और जब 2012 में ये आयोजन हो रहा था, यहाँ एक मानसरोवर में ऑडिटोरियम है बहुत बड़ा, दीप मतलब स्मृति ऑडिटोरियम, तो वहाँ मुझे बताते हुए अच्छा लग रहा है कि एक ही मंच पर अनिल काकोडकर साहब के साथ लगभग 20 से 22 वाइस चांसलर्स अलग अलग यूनिवर्सिटीज के बैठे हुए थे। और एक अच्छी बात यह है कि माननीय अशोक गुप्ता जी भी वहाँ उपस्थित थे, तो उन्होंने भी इसको शुरू में ही इस चीज़ को बहुत आशीर्वाद और स्नेह दिया है और ये चीज़ें आगे बढ़ती ही चली जा रही है। उसके बाद 1 हुआ, 2 हुआ, 3 हुआ। जब 1 हुआ 2013 में, तो मैं आपको बताना चाहूँगा कि इंडियन साइंस कांग्रेस का 100th सेशन हो रहा था 2013 में। तब हम राजस्थान साइंस कांग्रेस का पहला सेशन कर रहे थे। तो ये पीछे आगे होने की बात नहीं है, लेकिन जब जागो तभी सवेरा वाली बात है। तो जब इंडियन साइंस कांग्रेस 100वां अधिवेशन कर रहे थे अपना कलकत्ता में, हम अपना यहाँ स्टार्ट कर रहे थे पहला। और उस समय के प्रधानमंत्री जी ने जब उनको हमने ये सारी बातें बताई किसी माध्यम से, तो उन्होंने अपना एक पर्सनल व्यक्तिगत पत्र हमें भेजा है और उसमें उन्होंने अपने साइन करके बहुत ही अच्छी बातें बताई। अब वो इस दुनिया में नहीं रहे, मैं उनको प्रणाम करता हूँ। अभी थोड़े दिन पहले की बात है, मनमोहन सिंह साहब चले गए। इसके अलावा अभी 2-3 दिन पहले, अच्छा कोई कंफ्यूजन है इसमें, तो ये मीडिया में आ गई थी ये खबर कि वो चले गए हैं उनकी। ओके, फिर माफी मांगते हुए मैं इसको दुरुस्त करना चाहूँगा। उन्होंने पत्र लिखा और स्नेह दिखाया राजस्थान के प्रति, और मुझे बाद में पता लगा कि राजस्थान यूनिवर्सिटी को भी वो एक ऐसा पत्र लिख चुके हैं जब यहाँ दूसरे लोग थे प्रोफेसर्स। उसमें उन्होंने लिखा था कि राजस्थान यूनिवर्सिटी वैज्ञानिक शोध के मामले में बहुत अच्छा काम करती है, कर रही है, और उनको और आगे बढ़ना चाहिए। ये जब 94 में इंडियन साइंस कांग्रेस का सेशन यहाँ हुआ था, उसके बाद कभी ये प्रधानमंत्री जी का ऐसा एक पत्र उनको मिला था, जैसा मुझे बताया गया बाद में। उसके बाद बहुत बड़े बड़े वैज्ञानिक संचेती साहब के आग्रह पर और बड़ी जो टीम बनी उसके आग्रह पर डॉक्टर पीसी व्यास जी ने इनिशिएट किया, परोदा साहब भी आए, फिर गोवर्धन मेहता साहब भी आए, और मैं आपको बता दूं कि मशेलकर साहब भी आए, फिर यूजीसी के चेयरमैन वेद प्रकाश जी उस समय थे, वो भी आए, और इंडियन नेशनल साइंस एकेडमी के प्रेसिडेंट जो थे उस समय वो भी आए। तो वो सब लोगों ने आके स्नेह दिया और उन सब ने यही बात कही कि राजस्थान में अगर ऐसा कोई प्लेटफॉर्म आ रहा है, विकसित हो रहा है, तो ये बहुत ही अच्छी बात है राजस्थान के युवाओं के लिए और इसको आगे बढ़ना चाहिए। हमारी गुड ब्लेसिंग्स आपके साथ हैं, इसको बढ़ाइए। अब 8वां सत्र आईआईएस जैसी एक प्रतिष्ठित यूनिवर्सिटी में हो रहा है और मुझे बताते हुए प्रसन्नता है कि अगला जो 9वां सत्र है तो वो भी तय हो गया है। अब वो जोबनेर में होगा, एग्रीकल्चर यूनिवर्सिटी है वहाँ पर, उनके वीसी साहब ने सहमति दे दी है और वो शायद 22 तारीख को यहाँ आएंगे भी। इन सब चीज़ों के बाद में एक चीज़ और बताना चाहूँगा कि ऑडियंस में मेरे यहाँ पीएचडी के गुरुजी बैठे हुए हैं, डॉक्टर कंपोज कुमार जी, वो डीएसटी के डायरेक्टर भी हैं एनसीएसटीसी के, मैं उनको प्रणाम करता हूँ और ये बताना चाहता हूँ कि उनके मार्गदर्शन में ही सारी चीज़ें हम पूरे स्टेट में चला रहे हैं, देश में चला रहे हैं। वैज्ञानिक दृष्टिकोण न्यूज़ का जो न्यूज़पेपर है वो भी उनकी लीडरशिप में ही आगे बढ़ रहा है और वो 22 साल तक पाक्षिक था, अब वो दैनिक होने वाला है। हमने प्रधानमंत्री जी से समय मांगा है उसको रिलीज करने के लिए, जैसे ही सब कुछ होगा हम आपको भी बताएंगे। बहुत बहुत धन्यवाद।
Thank you, sir. To understand more about the Congress, may I request Dr. Y.K. Vijay, Chairman Rajasthan Science Congress, to please come forward and say a few words.
नमस्कार सभी को। मंच पे आसीन अशोक गुप्ता साहब, आदरणीय मुद्दा मैडम, टीएन भटनागर साहब एंड मेरे सर साथी शर्मा साहब, शिमोई, the whole team, हम लोगों को राजस्थान साइंस कांग्रेस आयोजन करने की जिम्मेदारी 2 साल पहले उदयपुर लास्ट जो कन्वेंशन हुई थी उसमें दी गई थी। सहर्ष हमने स्वीकार किया। अनफॉर्चुनेटली कोविड सिचुएशन के कारण ये हमें पोस्टपोन करना पड़ा, जो हमें 2020 में करना था। अभी ये 2021 में हमने जब गवर्नमेंट का आदेश आया सितंबर में कि स्कूल खुल सकते हैं एंड हम ये फिजिकल मोड में एक्टिविटी कर सकते हैं फॉर द नेक्स्ट जनरेशन टू शोकेस आवर स्ट्रेंथ एंड पोटेंशियल ऑफ साइंस एंड टेक्नोलॉजी। एस के गुप्ता साहब से हमारी मुलाकात सितंबर में हुई और उसी समय ये हमने फिजिकल एंड थोड़ा सा हाइब्रिड मोड रख के कोविड प्रोटोकॉल फॉलो करते हुए इसको करने की कोशिश की। तो हमारा जो ड्रीम था राजस्थान साइंस कांग्रेस को शेप देने का, वह सक्सेसफुल हुआ आज। उसके लिए हम बहुत हर्षित हैं। द होल टीम ऑफ IS यूनिवर्सिटी एज a host is working together and bringing out this Rajasthan Science Congress as a effort in the physical mode. We have contacted about 70 schools around Jaipur and Rajasthan, जहाँ के बच्चे शोकेस कर पाएँ, आके देख पाएँ हम जो यहाँ एग्जिबिट करना चाहते हैं। एग्जिबिट के लिए सबसे पहले मैं आभारी हूँ एस के गुप्ता साहब का, DPMO ऑफिस से जो हमारे साथ हैं। इन्होंने सहर्ष कहा कि हम भी 2 साल से रुके हुए हैं, कहीं जा नहीं रहे फिजिकल मोड में, और यदि आप ये एफर्ट कर रहे हैं तो हम सहयोग देंगे। सो थैंक यू सो मच सर। और उसी के साथ ये चेन बढ़ती गई। DRDO से व्यास जी एंड काफ़ी सीनियर साइंटिस्ट महेश जी यहाँ हैं, वो भी आए हैं पूरी टीम को लेके 12 लोगों की। एटॉमिक मिनरल डिवीज़न जो कि राजस्थान में ही है, जयपुर में ऑफिस उनका, एंड दे आर विद देयर टीम टू शोकेस द पोटेंशियल ऑफ राजस्थान, scientific potential of Rajasthan to our young children. So we are having a wonderful exhibition. Along with that, as Gupta sir suggested, we should have some eminent people to speak about the growth of science and technology countrywide. संचेती सर हैप्पीली रेडी हुए फिजिकल मोड में आने के लिए, एंड और भी सहयोगी फिजिकल मोड में आने के लिए तैयार हो गए। So we are having about 20 speeches in this hall. They will be spread over the 3 days. Along with that, we have a wonderful exhibition downstairs. All lunch, lunch will be served, working lunch will be served for most of the participants, maintaining the social protocol, and it will be hygienic within our canteen. It will be served. So for all of you, the lunch will be served here. For exhibits, after lunch, you have free time up to 4 o'clock. You can interact, but in morning session, we will have these special guest lectures. About 4 lectures, the speaker could not come physically because of the inability. We will have an online board, and the presentation will be there on display. I'm happy a team of about 20 students from Ganganagar, they have eagerly waiting here to listen to dignitaries and see the exhibition. They are here. And in the same way, a team from Kanodia College, University of Rajasthan, and Subodh College, they are participants basically. They are very eager to listen to dignified people, speakers here in the conference, and enjoy the science exhibition display. We have got an innovation hub here, which has a motive to teach science through laboratory experiments. So we like to showcase, especially to all the children, that is how if you study the science by playing, you will learn efficiently, and you can share this idea to your colleague, and certainly you can take it to your profession later on once you understand the concept. very well. So the sustainability part comes from the demonstrations, and that is what the theme we are trying to explore, exploit. So most of the speakers we have requested to bring their advanced concepts at the level where the young generation can be made familiarized and feel comfortable to take forward the science and technology for sustainable development on Mother Earth. With this theme, I welcome you all to the exhibition once the inauguration function is over. Thank you.
Thank you, sir. To enlighten us more on the vision of the state of Rajasthan in science and technology, I now request the chief guest of the event, Ms. Mugdha Sinha, Secretary, Department of Science and Technology, Rajasthan, to please come forward and say a few words.
A very good morning to everyone. Respected Dr. Ashok Gupta ji, Chairperson of IAS University, Dean University, uh, Professor Dr. Mathur, Vice Chancellor Professor Vijay, who's invited me, Tarun Vijay ji, Professor Sanjay ji, Shimoy ji, and Rector and Registrar Dr. Rathi Gupta ji. Guests, exhibitors, faculty, and dear students. Thank you very much for inviting me today, for giving me an exposure, because every event that I attend actually becomes a learning platform for me. So I'm very, very grateful for this opportunity of interacting with everybody. My compliments to the entire team of IIASC, of college, university, and also of Tarun Vijay and everybody who's organizing the 8th edition of the Rajasthan Science Congress here in this university. So compliments to all of you for doing this, for keeping uh, the flag of science flying high, because in the last 2 years of the pandemic, one has seen that research, science, and technology is actually what will ensure the survival of humanity in times to come. So thank you. I was just thinking that since the theme of this, uh, Rajasthan Science Congress 8th edition is talking of sustainability, let us compare when we talk of sustainability, what are we actually talking of? And after having deliberated a little bit on my own vision of sustainability, probably I'll also share what the Department of Science and Technology in Rajasthan is doing in various verticals of science and technology, which I prefer to call STRIDE. Uh, sustainability is dependent on time. You know, if somebody could tell me, if somebody from the science stream could tell me, what is the difference between my standing here and some of us sitting there in terms of time? And I can give you a small hint. It has some relation with Einstein. Is there any student who would like to take with show of hands, tell me what happens with people sitting on the dais and with people sitting down below in terms of elevation with respect to time, something that Einstein actually understood much before it was observed by the clocks and the watches. Okay, so it is believed that time moves slowly at places which are on the sea level, and time moves faster in the hills or the mountains. So any elevation in terms of height will lead to a difference in the order of time. And this can be measured by the very mechanical precision clocks. And why is it important? It is important because it defines what science is. When we talk of what the Constitution tells us about developing a scientific temper, which is a mandate of the Department of Science and Technology, be it in Government of India, be it in any of the states, including the state of Rajasthan, we talk of our primary aim behind doing anything that we do is to develop a scientific temperament. What is developing of a scientific temperament got to do with Einstein's time? Hold on to the thought because I have to tell you something more interesting. If people who heard of Aristotle, Aristotle said that time is nothing but a measurement of change, right? And which is depicted by the mechanical clocks. The mechanical clocks came into existence only in the 14th century. Before that, people who were riding on horses and walking it down were actually using the rhythm of nature, which is from dawn, which is the rise of 1 hour after sunrise, to dusk, which is 1 hour post sunset. The mechanical clocks came into existence during the age of enlightenment, which is the 14th century, which is exactly the time when the age of agriculture and the age of the first industrial revolution came into being. Why is it important? Because today, when we talk of changes which impact sustainability, we talk of the Industrial Revolution version 4.0, which also includes Made in India, right? If you look at what is happening in the age of information technology, because that is also a part of the Department of Science and Technology, you will see that the age of internet began in the 1980s, right? Then in the 1990s, you had concerns regarding security, right? Then in the 2000s, you had the 2K generation come into being. And then you had the age of digital technology, which is what we are living in today. It is assumed and it is believed that there is research going on in emerging technologies, which began in the 1950s with the advent of the nuclear age, which will take us into the age of imagination and creativity. In fact, 1950 is also very, very important in terms of sustainability because we had a change from the age of Holocene to the age of the Anthropocene, which basically means the change that is happening in nature and climate and environment because of actions of man, which basically came about because of the great Heinsberg experiment, the Manhattan experiment, which happened, followed by what happened in Japan, in Nagasaki and Hiroshima, which actually made people coin the term that the change in temperature is also happening because we are mining plutonium and uranium and doing what you call weaponization using the products of nature. So 1950 became very, very important from that point of view. And we are still today living in that age where we can see disasters. We are all aware in the last 3 days, it has been raining incessantly in Kerala. And if you've seen images of what is happening in Kerala, you will see that it is very, very bad in terms of floods, actually, flash floods, actually throwing away huge buildings, raising them to the ground, washing away cars and people. It's a disaster of the kind of 2013 that we saw. For the first time in many years, New York, a city, has experienced floods right at the heart of the city in modern day imagination. Very, very difficult. If you look at Australia, you are finding that Australia and California, the forests are ablaze with one fire after another. If you look at why this is happening, it's because we have removed ourselves from traditional knowledge. In fact, in Australia, there was a practice by the Aborigines of lighting small cold fires. Had these undergrowths, and these Aborigines would go in the forest and light small coal fires to take care of the undergrowth. With the advent of modern man, with his hubris or arrogance that I know best, that I know everything, and that I don't need the knowledge of these aborigines who are not modern men and women. Today, Australia and California is beset with forest fires, the likes of which we've never seen in ancient times. If you come closer home in the Andaman and the Nicobars, in those places where you still have the aborigines, they survived the worst kind of cyclone that we had, based only on the traditional knowledge that they had, that the moment you see the sea or the ocean recede, that is an indication for you to move up the hill. No amount of weather stations, no amount of precise warnings could match the indigenous knowledge of those people. None of them died in the cyclone that impacted Andaman and Nicobar a few years back, based only on the traditional knowledge. So if you connect the dots, you will find science is only about connecting dots. So if you connect the dots from California to Australia to Andaman Nicobar, you will find that today the reason why I'm standing here at the 8th Rajasthan Science Congress and talking about sustainability is because we've done two things. We've moved away from living in sync with nature. We've brought about the advent of the Anthropocene, the age of the Anthropocene, the age of man-made disasters. And second, we have refused to amalgamate or to study or to understand the vast body of traditional knowledge that is everywhere around us in the people who are actually the harbingers of humanity, the bridges that connect our past to our future. Coming back to both Einstein and Aristotle and solving this riddle and placing it in the context of the sustainability that we are talking of today. So as we all know, the only thing that changes, the only thing that remains constant is that change is always happening, and that's the only constant thing. So what is time measuring? Time is measuring change, and change is constant. Because the more we change, the more we remain the same. The more intelligent we become, the more fires we continue to have in our backyards. So what is the Department of Science and Technology doing in inculcating this scientific temperament among students, both at the school and the college level? And what are we doing at a macro level in terms of research, in terms of innovation, to tackle this great problem that surrounds us all? Because our own survival is linked to the survival of this earth. And as we can see, that small steps have already been taken in full awareness of the fact that we need to explore other spaces for habitation of man, beginning with Chandrayaan and Mangalayan, everything that both India and people abroad, the Elon Musk and NASA's are doing, and now also a move in Trojan to explore Jupiter. So we are actually bringing everything together. So from being global citizens, we are now going to become citizens of the cosmos, of the universe. But what have we learned in the process? What we need to understand is that based on what Einstein understood, based on what Anaximander understood, based on what Copernicus, Galileo, and so many scientists before us understood, is that the basic principle of science, apart from the fact that it is dynamic, is also that you should be able to understand things much before those things can come under observation. Einstein understood that time moves differently because he was working in the patent office where they were talking in 1883 of standardization of times in different time zones when the mechanical clocks came, because by that time telegraphs and trains have also come into being. So lest person from one time zone miss the train, it was required that we standardize time within the time zones. And that is how the concept moving from the order of time to the physical mechanical time came into being. But why do we appreciate Einstein so much or scientists so much? Because scientists are able to understand things before the world can go out in the laboratory and observe them in the real physical world. How does this definition of being a scientist align with being a science administrator or a science policy maker, which is my role? Just as a good scientist is able to understand before observation, similarly, a good science administrator or a good science student or a good science professor is able to understand and anticipate the future much before the future happens. Because it is exactly on this axis and praxis, the theory and practice of it all, that research relies, that research rests. And that is why technologies which were under research in the 1950s are today becoming the emerging and new technologies of today. So now I will speak about a little bit about what my department is doing. We are all aware that Government of India, just like Tarun Vijayji's organization, is doing what is called the Rajasthan Science Congress as an initiative between private universities and citizen scientists, which are all, everybody. Today, everybody can aspire to be a citizen scientist because we believe in open science. Rajasthan, the department has already approved a policy for open science, for collaboration in science, for developing citizen scientists. The government of India also does what is called the Children's Science Congress and the National Science Day celebrations, which we have been doing for the last 2 years with great aplomb. Only last year, we had nothing because of the lockdown, so we didn't even have an online thing as far as the Children's Science Congress is concerned, because the children were overloaded with too many online sessions. But this year we plan to have. We've also advertised, and I'll be happy to have applications in our Stride Awards, which basically we'll be giving 3 awards, which has been approved by the government. There'll be cash prizes for each award, which is for a young scientist, which is for a science uh, communicator come journalist, and one for encouraging women in science. Last year, we also did something called the Stride Conclave, which was attended by all 3 secretaries, Government of India, of DST, DBT, and GPIIT. We also did what is called the Nari Vigyan Utsav, which was focused on the 11 pioneering women scientists of India, on whom 11 chairs have been dedicated. And we got the Indian Academy of Science at Bangalore to organize the discussion around our pioneering women scientists. Now books are coming out in the market, both in graphic, comic, and non-fiction category, which seem to encourage children, especially the science students, to understand about women scientists. The government of Rajasthan has also started, through its budget announcement, something called the Rajasthan Space and Science Clubs for Sarkari and non-Sarkari schools. We've dedicated a Facebook page, and we have about more than 5,000 schools who have become part of the space and science community of Rajasthan. We are also encouraging our students across the government and non-government schools and colleges to participate in a campaign which has been started by the IASC NASA, which has been emulated by Government of India after the Rajasthan government made an announcement in the budget. And the Government of India campaign is called Khagol Shastra. And we've been doing it For the last 2 years, we started it in the lockdown, and we have about 500 preliminary discoveries of asteroids which have been made specifically by students of Rajasthan from Rajasthan, and we hope to take this further. Children will get certificates from NASA, and I will encourage IISC school community also to participate along with their students. What we have recently started, also available on a Facebook page, the IIS community can also join if they wish, which is what is called career counseling in science, in basic science streams, which is very important today. We are making institutions, the 33 CSIR institutions, the scientific labs, in which our children go for career programs, for attachments as science lab assistants to do their internship projects. Now, what we are also encouraging is for these 33 institutions to talk about opportunities available for people who have done their undergraduate and postgraduate in science streams, in terms of employment opportunities, in terms of opportunities for being editors for journals, in-house journals, also opportunities for fellowships and scholarships in science. So it is very, very important that if you join the Facebook page, regular updates. We've also started a series called Let's Know Our Scientists. So we'll be talking of scientists, focus on women scientists in times to come. Uh, Something interested we did with art and culture when I was also holding that department is we started what is called Astro Night Sky Tourism, something which is also caught up all around India with Nainital and Ladakh also emulating us in starting their own Astro Night Sky Tourism, Ladakh in Handley and Uttar Pradesh government in Nainital, which is very, very heartening that two of our initiatives have caught up in other states as well. The other interesting thing that has happened is that we live in a state of Rajasthan, which actually has a very, very scientific feudal history, if I can just say that. Raja Savai Jai Singh Ji started what is called the Jantar Mandir, an entire monument devoted to study of astronomy. We're very happy to connect the ancient indigenous knowledge of not so old with what is happening today in the sky with astronomy, and taking this further, because of which Time magazine has also heralded two cities in India, including Jaipur, as the astronomical city in India, which is very, very heartening for all the science community. Happy to also tell you that we sponsor a lot of workshops in various colleges and universities. Um, but I only see the same universities and colleges who are aware approach us for those fundings. So I'm very happy to also have IISC apply for any kind of workshops or conferences or seminars they'd like to do surrounded or around scientific topics. There's a whole host of things that we are doing in terms of scholarship, biodiversity, because we are talking of sustainability. We'll be happy to fund research in new materials, because actually it is the new materials which will propel our understanding of sustainability. Because the moment you say ban plastics, what next? What is the alternate that you can offer society? Because the idea of science is to find solutions for society. So I'll be very, very happy to hear of anything interesting that is being done. If you want to take up long-term research in any of the emerging technologies, I'm happy to help. We are doing a lot of digitization of museums using AR, VR, and MR technologies. So if anybody is interested in taking up or learning, if students are interested in doing internships with the department, we have paid internships at SATCOM. We've just recently held interviews and taken free interns, uh, also from the Department of Mass Communication. So the three interns are working with us. So I'll be very, very happy to have the IIS University and its students collaborate and work with the department to gain experience. What I also find is when you work with the government department and do voluntary work, it also enables professors and students to then apply for admissions abroad, because in most of the admission forms, voluntary work with government organization is something that tilts your resume in a more positive direction. So that is what we've started doing based on suggestions that we've received from some students. So please feel free to use the government department to work in collaboration with the government department, because if you want to do things in the long term in a more sustainable manner, then we will all have to sync our understanding, our efforts, and our initiative in sync with what the government objectives are. And the best way to figure out what the government objectives are to look at the budget announcements, be it for the state of Rajasthan or be it for the government of India overall, because that is the framework of reference. As Einstein said, if you have a framework of reference, you will be able to work in sync, in collaboration. With these words, I wish the Rajasthan Science Congress all the 3 days of deliberations, all success. And I wish the entire team that is steering this initiative to take this forward. And may we also have the benefit of seeing this to its logical conclusion in terms of recommendations. I'll be happy to have a copy of the recommendations that emerge from the 3 days of deliberations. And if there's anything that you want us to do in terms of furthering this initiative further, I'll be more than happy, understanding in sync with the government priorities, in sync with the government objectives, to take this forward. To all the students who are participating, please remain curious, please observe, please experiment, please explore, not just your studies, but also yourself and nature. Find your place in life, find your place in nature, and may you live long, sustainable lives. Thank you and good luck. All the best to you.
Thank you, ma'am. May I now request all the dignitaries on the dais to please release the souvenir of the 8th Rajasthan Science Congress. Thank you all. I now invite Dr. Srimoy Chatterjee, Organizing Secretary, Rajasthan Science Congress, to please deliver the vote of thanks.
Namaskar. Honorable Chancellor, IIS Dean to the University, Dr. Ashok Gupta, Chief Guest of the inaugural ceremony, Ms. Mugdha Sinha, Honorable Secretary, Department of Science and Technology, Government of Rajasthan, Dr. Sandeep Sancheti, Vice Chancellor, Marwari University, Rajkot, Dr. P.N. Mathur, Vice Chancellor, IIS Dean to the University, dignitaries on and off the day, and dear participants. It is my proud privilege and honor to propose a formal vote of thanks on behalf of IIS Dean to the University at the 8th Rajasthan Science Congress on Science and Technology for Sustainable Development. I am extremely grateful to the Honorable Secretary, Ms. Mugdha Sinha, for acceding to our request to inaugurate this Science Congress. Your presence today, ma'am, has indeed boosted our morale tremendously and proves without a doubt your commitment to the cause of strengthening the fabric of higher education in our country. Your views about traditional knowledge in preserving nature and far-sightedness of scientists will guide us in future. I also take this opportunity to thank Dr. Sandeep Sancheti for consenting to deliver the keynote address. Sir, your talk today on the topic Education 4.0, redefining the higher education, will enlighten the faculty and young students with the need that how higher education is going to transform the era of fourth industrial revolution. My thanks are due to Dr. Ashok Gupta, Honorable Chancellor IIS Dean to the University, for his unstinted support and invaluable guidance throughout, which have given this three-day event its present shape. I also thank Professor T.N. Mathur, Honorable Vice Chancellor of the University, for his motivation and support. I take this opportunity to convey my heartfelt thanks to Professor Y.K. Vijay. Sir, your unfailing support since the initial stages of planning and conceptualization of this event has been vital. May I also thank Mr. Tarun Jain, editor VDS and convener 8th Rajasthan Science Congress for his constant support. I am thankful to all our eminent resource persons who have so graciously consented to deliver the invited talks. I am sure that your contribution to this conference will prove to be invaluable and of immense intellectual significance. I am also grateful to Dr. Rakhi Gupta, Registrar IIS Dean to the University, for the meticulous planning and attention to detail in the organizing of this event. I would express my thanks to Professor K. Sharma, advisor, and Professor Pradeep Bhatnagar, Dean, Faculty of Science at the University, for so very ably steering us all in the right direction towards making the event see the light of day. I also acknowledge the presence of all the participants. Your active and wholehearted participation during these 3 days will definitely guide you in near future. I hope that the interactive sessions and scientific discussions will be an enriching experience for one and all. I close by thanking the faculty members and the support staff of the university for their complete involvement towards making this endeavor take its current form. Last but not the least, I thank all the media persons whose ample coverage of this Congress will bring the vital issues related to sustainable development closer to public interest and notice. Thank you all once again. Thank you.
Thank you, ma'am. With this, we conclude the inaugural ceremony of the 8th Rajasthan Science Congress. Thank you all for gracing us with your presence today. May I now request all dignitaries to please take their seats in the audience. We will shortly begin with the keynote session of the
BRNS, GARC, and probably other defense organizations, and also from the DST of Rajasthan and India. Friends, I'm going to take half an hour time. This is what has been given to me. I hope it will not be an overrun, but you can warn me if there is some overrun. And very happy to be sharing this dais now because already the tone has been set in the morning session, inaugural session by the different dignitaries, particularly the Secretary of Science and Technology, Madam Sinha, who spoke very fluently about the importance of science and some of the activities which the departments are doing, and various other things which are happening in this domain and how students can take advantage of it. I'm also going to be in the same wavelength, I would say, in terms of sharing my views. I would be very happy if there are some questions you have, you reserve them for the later part or in the end, in case you'd like to know something from me, because your insights are more important than what we are trying to share. That's not very, very important in my opinion. So I'm very much available after my session till probably lunchtime or a little later to answer any queries if there are some of them. So I think with that background, I would like to make a start. Would also like to thank all their experts to join this session. Professor Mathur, the Vice Chancellor of IIS University, also to be there. Professor Vijay was sitting in the front. Everyone else for joining the session. I would now move ahead with my initial introduction as Sri Tarun Jain, who was making a mention. Rajasthan Science Congress is a movement and started probably 9-10 years back. And the first version happened in 2013. And I have been associated with 4 or 5 versions, one which happened in K.N. Modi University, another one in Manipal University, Jaipur, where I was the Vice Chancellor, later in MET and also JKLU. And after that, I left Jaipur. So I don't necessarily remember where it happened, but this is another opportunity to join you back. And this movement is a good movement because a lot of who is who of Indian science have joined this movement. Mr. Tarun Jain from Vagyanik Drishtikon has already highlighted some of the names, but some of the names which are probably missing might be Professor R.S. Paroda, who is the agriculture's who is who, Padma Shri awardee, and also Professor M.M. Sharma from the chemical sciences or chemical domain, who has been awarded all the 3 Padmas way back, some 15-20 years back. He is recipient of all the 3 Padmas. They have all kind of graced the occasion of Rajasthan Science Congress. So I actually come from engineering background, but I would generally say that I perceive, or my perception is that there's hardly any difference between science and engineering today. If my life is made, and if I'm today an engineer, it's probably because of the sciences, which were my foundation. And to give you an example of some of those things which are there, you can probably see the names which I'm calling them as technology, you can say information technology, biotechnology, materials technology, or nanotechnology, are equally applicable to what you call nanoscience, material science, biosciences, and computer science and engineering. All these are. So there is hardly any differentiation, and people should not perceive. They are merging. And to make sure that these things are there, I have done my part that whichever institution I have headed in my life, which I've done around 11 or 12 of them, I always made sure that science and engineering goes hand in hand. And there are programs which are of that nature available and offered. But now you will see IITs and IISERs and IAFC and NITs. All of them are offering science program as well as engineering programs. And all of them are, of course, offering some other programs of management, humanities, and maybe in certain cases, liberal arts also are included. And therefore, you can say that this is how the science and engineering are getting merged. But I'm an electronics engineer, and I would say without physics and existence of physics, nothing, there would be hardly anything in electronics itself, as my personal example. Every new thing which is coming in the domain of electronics in terms of devices or fabrication or application, I think the fundamentals are sitting somewhere in the sciences of physics. All right. So that's the, you can say connection, we can say. And of course, education and research connects to all of them. And that is the reason why I'm talking about the education. If you've seen the brief I've given, I've clearly said that education is one pill for all the ills, whether it is hunger or poverty or the quality of education, or it is something else in terms of environmental awareness or dealing with the issues like pandemic. If you are educated, the chances of your success and coming out of that would be something very high. And therefore, education and research connects all of them. Pancharya Saab is here. He does a lot of research like we do a lot of teaching, but both of us also do the other side of it. We do research and they will also do the teaching, as we were discussing just now before the start of the session. And we know that everything has now become well connected to each other and multidimensional. Why I'm taking example of mobile here is because mobile is a device which does almost everything for you. It's your doctor, it's your sensor, it's your ID, it's your camera, it's your music machine, it's communication, it's torch, light, whatever it can be, projection system. And of course, it does all that communication which you need, audio and video, everything. And if you see, science and engineering gets merged there. If I'm saying that mobile is an electronic device, I would call it's wrong from my side. Mobile has only one chip called an integrated chip, which does everything which is required in electronics. But most of the mobile in terms of weight, volume, capacity, and functionality is something beyond electronics also. And therefore, we should merge science and something like that. That's my suggestion to you. The next one is I'm going to discuss something about the education, particularly in the light of NEP. I'm sure there are some students here, there are some faculties here, and they will find it enlightening in terms of what are the potentials and what are the changes and what are the new things which are available to us in that this thing. And NEP drives all of them cohesively because NEP says that don't distinguish between one domain to another and vice versa. And of course, the key beneficiaries of that would be none other than the students. Students will be the real beneficiaries. Till now, we were not very student defined or student controlled or student driven. And therefore, this will be the key beneficiary. And I'm going to discuss about a term, maybe you can call it fast, doesn't matter, it's not required. I'm going to discuss about faculty, autonomy, students, and technology, these four aspects. On each one of them, I've just put 3 slides because I know there are limitations of the time which are there. I will not be able to discuss much, and I'll try to throw open some ideas and some challenges and some answers which are there. Not necessarily in the same order. I'll not discuss faculty first. In fact, I'll discuss the students first, and then maybe autonomy, and then faculty and technology. In that order, I'll discuss it. But you can say that these are something strong pillars of the education today. And since you talked about sustainable development, as I told you, SDGs will not be attained without good quality of education. So education will be a prime driver for what you call the sustainable development. In my note, I already said it is one pill for all the ills which are there. It can also be one pill for all the skills which can be there. It can also be one pill for all the thrills, if you so like, that Professor Vijay will give you with lots of physics related demonstrations and tools which are hanging around and which are in your campus. These can be very wonderful. So education can be something very nice. And that's why I'm talking about this as a theme lecture. When this opportunity was given to me, I decided about that. Talking about our education, don't pay too much heed on this. This is my own analysis in terms of what is the strength of the current Indian higher education system. And based on that, there are various parameters. One, we are growing very largely. Number two, we have diversity. Number three, we have keenness to improve quality. All this ranking, rating, accreditation, NIRF, NBA, NAC, everything is coming under that. And then, of course, new and challenging frameworks. The foreign institutions are coming in. And then, of course, government has given a new framework of NEP. So probably in this slide that we want to build on our strength, I've shown you this slide. In the same fashion, the weaknesses, if I'm saying so, what are the weaknesses of the Indian higher education system? There can be many. You may disagree with me. but I will agree with you. If you disagree with me, doesn't matter, because it's open field. It's your perception, my perception. And in that case, we don't understand how to operate well, neither the students, nor the teachers, nor the institutional heads, unfortunately. Autonomy is a big challenge. Faculty is a big challenge. Limited research is a big challenge. And of course, what do we require out of our manpower is not known. AICTs and UGCs are not telling how many these engineers or scientists or researchers we require. We don't have any such numbers coming, any such disciplines coming. And therefore, there are challenges. But more important for me is we are in a trap where we are in slow moving systems, whereas the world is changing very fast. And these are the weaknesses. Fortunately for us, these are getting addressed partly by NEP and partly it has to be addressed by us, which I'll probably try to show you in the my last slide. Now, if I come to the NEP itself, I'm sure most of you know, you can say National Education Policy, or NEP can also be New Education Policy, or it can also be NEP 2020. The terms are used exchangeably. And of course, it has come out of this thing in its presence after long efforts, after 34 years and so many committees and so many other things which were there. We have seen this has seen the light of the day. Here, if I talk about, these are the weaknesses or drivers for change listed by the NEP team itself, led by Dr. Kasturi Rangan. I hope you know Dr. Kasturi Rangan, who is who of the space and also the member of parliament and of course various other things. But more than that, he was the driver for the new education policy. And they have listed all these are the weaknesses which are there in the education system. And that's why we need new education policy. Now, in the same education policy document, they have given these as answers. Okay, one is the ecosystem is not good. So ecosystem is a wholesome term. But if you look at this rigid separation of disciplines, they are now going to give you courses, choice of courses by undergoing a scheme called ABC, which government has come out with in the NEP itself. I'm going to give you one slide on ABC. Similarly, till now, the enrollment of students in the higher education was pretty poor, which is around 25-27%. It is going to go up by 50%. And not only that, it will be on the increasing base of the population. If the population right now is 1.38 billion, it may be 1.5 billion by the time we are trying to achieve that, something like that. So it's increasing. So you will see a lot of flourishing universities, new universities, institutions coming up. And that's how the GER will go. And just to give an example, many of you might dream to go to IIT or some IIT. I'm just giving an IIT Madras case that using the cloud-based technologies and online methods and all that, they started a program on data sciences, BSc or undergraduate program on data sciences. And they were enrolled thousands and thousands of students. And IIT, where even one seat increase or 100 seat increase, 50 seat increase would have been difficult, all of a sudden gives you an option where you can have hundreds and thousands of seats which are there. So access will increase. Similarly, teachers will have a lot of autonomy to how to teach by taking you to the site or giving you exercises, problem solving, and taking you to industry, making you do projects, problem-based solving, and all that kind of things will be there. Otherwise, the poor teachers were confined to the classroom, and you were also confined to the classroom in only blackboard or whiteboard activity was the teaching thing. Research emphasis was not there. So once again, all these green solutions which I'm talking about here are the ones given by the NEP itself and its document. Similarly, you can see that the governance was poor, leadership was poor. So they're trying to bring out IT-based systems and transparency and ERP. Ineffective regulatory system. So there will be a new higher education regulatory system named after HECI, and then it will also have few more pillars to support it. And that's how the higher education system will further improve. Will probably have a ceasing of existence of what we call AICT and UGC, if everything comes true as they have said there. And then finally, large affiliating university. India currently has around 1,000 universities, only 1,000 universities giving degrees to all the students who are currently graduating. Very soon, the number will rise to what we call 10,000 students in terms of degrees which are there. All right. So there will be large number of universities which you'll see in times to come. So these are some of the changes and these are some of the solutions which are listed here. Okay, but the most important for you can possibly say in terms of growth would be the for the students is that they will have a lot of access. They can choose the institutions more freely, and they'll also do the lot of blended teaching and learning for their own good. If I'm hearing impaired, I'll probably do more classes which are based on video and other things which are there. If I'm writing impaired, I don't have a hand or something has happened to my hand, I'll probably do mostly my examinations as audio examinations than written examinations. So I can use a lot of technology to support my case, and both for learning as well as for examination. So if I go to now important aspects of the what we call NEP, I'll not dwell upon all these points. These are the points which you are already continuing. What we now really need is the speed and efficiency with which we change and improve and grow, and all that is required. But the ones which are given in the blue are all meant for students. Students will have to take advantage of that. They should make a note of it that they can do a program which may be 3 year or 4 year. 4 year program can become 3.5 years right now, and a 3 year can become 4 years also. Vice versa is also true. You can reduce time, you can increase time. You can take multidisciplinary approach. You have come to science, you have liked it. You can change from physics to chemistry and merge them. Or if you don't like one of them, you can go to nanotechnology, nanoscience, and go to engineering. Still, you don't like everything. You can probably take something from arts, commerce, management, and all that. Even that would be possible. You can leave the education if something is required in your family that you discontinue the education. That can happen. So multiple entry and multiple exit with track changes. You can change the track from engineering to science and vice versa would also be there. You can also merge the vocational and skilled courses. I think that's where the Science Congress would be much more interested, because we want to talk about the skills, and I'm sure many experts are going to talk. But if you do skills, even those can earn you the credits, and then you can get the degrees out of that. You don't have to get a B walk kind of a degree if you're doing vocational courses. You can get a normal degree. For general degrees, you can do it. And then, of course, right now we see the online education and the open and distance learning with some disdain, with some disrespect, I would say, or maybe industry or society is not giving its due. But that is going to improve very soon, and that's how the acceptability of the online and distance will also happen. And finally, many of us feel completely inhibited in terms of the language. I still remember that when I went to my first physics class and it was in English, I was really very pathetic in the sense I felt uncomfortable with myself that they talked about matter. I didn't know what matter is. They talked solid. I didn't know what solid is. They talked liquid. Also, the word was not known to me. Only the word gas. They explained the matter in three forms. And when they talked gas, yes, gas was a word used in Hindi also. So probably I knew. So that was the limitation. And during our times, the books were not there for us to read from that. We were only having high level books from foreign authors, and there was a lot of difficulty. So this will be a boon if it happens to the students. And you should remember, all these things should be offered to you gradually as and when it's needed, or as and when you'd like to use it. Similarly, the last slide on the NEP, I would say, is the NEP also supports mature learners. Today you might be young, tomorrow you'll be mature, 25, 30, 40, 50. You'll work up to 70, 80. You cannot come and sit in the class every time to do something. And therefore, mature learners will be dealt differently. Internationalization to increase diversity will be there. You can take 2 courses or 1 semester or half a semester, or maybe 1 full year, or maybe half a degree, twinning and dual and various other forms are there integrated, can also happen. Blended teaching learning would follow. I've already given you example of that, how it can happen. Industry connect or relevance through internships and projects and problem solving will happen. Examination reforms will be like open book and on demand. Like you eat on demand, you sleep on demand, you wear the clothes which you like on demand, that this is the occasion. Similarly, examination will also happen on demand in times to come. And for all those things, the answer would be ABC, the Academic Bank of Credit, which is a very fundamental scheme. You should read more about it. The Prime Minister launched it on 29th of July this year. Of course, a committee worked on that, of which I was also part for a long time. And that's how the scheme has come. And it gives you all the features of anytime, anywhere, any mode, language, etc., etc. And ultimately, this whole set of changes which I've listed to you in 2 slides makes the education as student centric, not teacher centric, not institution centric, not VC centric, nor AICT or UGC centric. It makes the student centric, and that's what we call as education 4.0. As Madam Sinha was talking about, or others were talking about industry 4.0, you now learn what is education 4.0. Education 4.0 is amalgamation of all these points which I have listed to you. All right. So I hope you will take advantage of that. And therefore, this is the most important thing for you to know. The more the functions available in a mobile, the more you can use it to your advantage. But unfortunately, most of us hardly use even 5 to 10% of the functionality available in the mobile. In the same way, you can say ABC gives you lots of functionality. It will depend upon you how to use it to your advantage. All right. The world will be yours. The freedom will be yours. The choice will be yours. Autonomy will be yours in choosing that. And that's how I have chosen this topic to excite the students that education will no more be an imposition on you. Education will be fun for you, which I think science does. Science can create things, destroy things, can shape things, can explain things, can make your understanding deeper. And I think that is what is probably needed now in education 4.0 or the changes which we are trying to bring. I hope you will understand the concept, but if you need to know more, please let me know. So I'll now talk about those past, the faculty, the autonomy, the students, and the technology. 3 slides each. I won't have enough time to explain everything to you. I wish I had long time, but it won't be possible. It won't be good also. So I'm first talking about the students. What a student would need in the current set of context. Not all conditions you need it. Different students will be different. But in general, if I'm talking about, a student will be very happy if he or she is able to pick teachers and the timings. They can decide which teacher will teach me at what time. I think that will be a wonderful thing if it happens. Similarly, frame my own courses based on the needs and interests. I want this course to be advanced, this course not to be advanced, this course in certain way with lab and in this course in theory only, something like that you can do. Similarly, I can design my degrees. I don't want a standard BA, BCom, BSc, and I can design my degree. Even that can happen through that. Now, these are the transformations which I'm trying to bring to your attention. Study through any mode. I'm lazy at getting up in the early morning or maybe late riser, and I can probably attend my first few classes through some other mode, and then I come to physical campus where interaction and all that. So real world, physical world. I want to do lab anytime I want. Right now, your labs are open from 10 to 4 or 9 to 4 or whatever the time may be. But then now you can do it 24 into 7. All the 7 days in a week, 24 hours, you can do your lab because labs can also be like that. And similarly, examinations on demand. खाना खाते हैं जब हमें भूख लगती है, बाहर जाते हैं घूमने जब घूमना चाहते हैं, पढ़ते हैं क्लास में जब हम पढ़ना चाहते हैं तभी क्लास में घुसते हैं, पर एग्जाम में हम पे वो कंट्रोल नहीं होता है. तो मे बी एग्जामिनेशंस ऑन डिमांड कैन आल्सो हैपन, एंड अल्टीमेटली दिस विल बी support to a student. That will be the desire of a student in the new framework of the education is what I'm trying to say. I'll not give more. I'll also give you one more interesting debate which is happening in the country, but unfortunately it was subdued because of pressures and withdrawals. Immediately on the day or day after it happened, I would like to reignite by using this platform, saying that we always have prerequisites. You want admission in BSc Science, BSc Physics, BSc or BTech Computer Science. You need some prerequisites which are there. Okay, maybe earlier there was a requirement of PCM when most of us studied. PCM was a requirement. Later, chemistry got removed for whatever reason, right or wrong. I'm not bothered, but it got removed or it was not mandated. All right. But now people are talking about remove physics also, and why only physics? Remove mathematics also, and this was a recent phenomena which happened this March or April. If you remember, AICT had come out with that. There was a lot of hue and cry. Can there be an engineer without this? I agree that there cannot be any engineer without mathematics. I accept that fully. I endorse that because my life is made full of mathematics. Had there been no mathematics, probably I would not have got entry into engineering at all. So I fully agree mathematics is important. But what if I have not studied mathematics till 12th standard and I'm ready to study it in my first year as a bridge course? What is wrong in it? Nothing wrong in it. If I give you the counter logic for that, I'll probably try to say that if I'm not, I started with science, but I'm not good at science, and suddenly I want to shift after my 12th in science to commerce. Why should commerce people take me? They can say, oh, you have not done the accountancy or basics of bookkeeping and this and that, or whatever such things they may require. Or arts people can say, you don't have any background of history or geography or whatever that may be, languages which is required. Why should we take you? So the point is, an engineering or science student can easily go to arts or commerce, but the commerce and science student, engineering student, commerce and arts students are not allowed to come to engineering. I think it's a wrong situation. If someone is lacking something, give them an opportunity. They can do half a year extra, one semester extra, one or two courses extra like that. And that's how you can say. So students should be allowed to change directions, gears, and speed. I'm just giving an automobile equivalent of your education. That if education is like an automobile, you are able to change, steer it, and monitor it, maneuver it, or whatever it you can do it. So that's how it should be there. So the point I'm trying to make to you is these prerequisite requirements for admission into engineering, in my opinion, are a misnomer, and we should rethink. I have found a lot of people with non-science background also doing wonderfully well in the science, and later if they want to come to engineering, there is nothing wrong. We should allow it. And for that, the answers are: number one, the bridge courses; number two, international admissions are full of such diversity. In US, in Australia, in Canada, in UK, if you go there, they consider your SOPs, they consider your knowledge, your innovation quotient, and give you admission in variety of programs, irrespective of your background sometimes. And then like at exit point, you can differ a lot. I may be an engineer, but I may become film director, film hero. I may become a cricketer like Srikanth and others who are there, Kumble and all that. I can become a politician like Nitish or Arvind Kejriwal or whatever. They're all engineers. I'm giving you those examples because one can choose any discipline at the exit. I can become an entrepreneur. I can run anything which I want to do as a sports person. So in the same fashion, when my entry points are exit points are flexible, why not my entry point should also be made flexible? That is the point I'm trying to bring to your attention. I want you to ponder over it and think about it, that how admission debate can help you choose the right career. I go to the last slide for my dear students, and I'll try to push it through quickly because of some points I might have explained. This ABC is a wonderful scheme, though government has not able to implement it in full, but slowly and gradually this will happen. You can take any subject combinations. You can merge regular distance online virtual modes. You can be a lifelong learner through this kind of a scheme at 75 or 60 or 40. I can learn any course and then get another degree and keep on accumulating degrees or credits and courses which are there. I can also study in any national or international institutions, partly or fully, or alternatively in whatever fashion I want. I can convert my credits into degrees and diplomas, or otherwise retain credits. That's also possible, like you retain your money, or you can convert them into some facilities or goods or whatever it may be. Like that in education, it can also happen. And if you are choosing curious combinations of science, commerce, arts, business kind of courses, you can still get a degree called liberal education, like liberal arts. You need not get engineering degree or medical degree or commerce or science degree. You'll get something like liberal education. So these are possible. And if you see some explanations I have given you, that they change the notions of many things. Notion of specialization is changes, interdisciplinary is changed, blended education model has come, mode of education. This is the slow and fast speed and multiple entry, multiple exit. Physical campus notion is changed. And then the educational currency is no more the degree and diploma. If I do, let's say I need 50 courses to be completed by me to earn a degree, and I do 49, and I'm not passing one tough subject for some reason, my life will become hell. I'll not get any degree even after 49, and I'm missing one course. So such remedies will come into this, that I can choose another course which I want, and make 50 courses, get a degree that may not be the same degree, but then I'll get a Bachelor of Liberal Education kind of a degree. Something of this nature can happen. So the world is going to change. And if still I'm not happy, world can give me cognizance of my credits. I can say that I know information security. I've done 5 courses. I've earned all the credits. Test me on that. I'll come through. And that's what is happening in the world. A lot of people in information security or cyber security space are not even graduates. They are not even intending to be a graduate. They have just become the expert, and the world is paying heed to them. IBMs and Cisco's and Googles and Microsofts are paying them high sum. I think Professor Vijay will be able to talk to you about that on such issues. So there's a lot changing in the education space. So this was all about the students, the 3 slides which I've shown you. This is more about the autonomy, that how should you be taught. Autonomy is to a teacher, autonomy is to a student also, that they can be taught by methods of blended teaching learning, lived classrooms, practice labs or virtual labs, as I was saying, 24/7, more design orientation or more theory orientation or more skill orientation, all that can be done. More research orientation can happen. Pace of teaching learning can change within a class. One can be slow, one can be fast. It has to be outcome oriented, as you all know from accreditation. There'll be better evaluation strategies which are required. Right now we are just doing the bookish evaluation of defined, derived, described, draw kind of a thing. These are not yielding very good results for Indian higher education, particularly at the top level. And then, of course, more active feedback. After every class, if you are able to give feedback, I think that will be wonderful to tell teacher whether today's class was good or bad, or you have understood the concept or not. And then, of course, use of AI tools. People have done class of 500 students and given personal attention to every student, because the AI tools are able to judge your body language, your eyes, your body reactions or facial reactions, and based on your other parameters and your previous data and available data, they can tell you how well you have received the education or the class today or not. So they are able to give. So that will be the autonomy. So autonomy will go to both students as well as faculty to how to deliver that. If I now go to the learning processes, I've intentionally used the learning process here because today it's less of teaching and more of learning. If previously it was 50-50 teaching learning, today it is less of teaching, more of learning. You have to have the ability to learn. A student has to learn. Teacher may not teach can also be a condition, because student can learn from many of variety of opportunities which are available. And therefore you can possibly say here that learning processes should be through generating ideas, brainstorming, concept mind mapping, maybe something like flow chart in common man's language, and then creative presentations, exposure to real world case studies, cooperative learning, problem solving. These are anyway happening, last year happening, but many of them are new in terms of the ideas which are there, which generally doesn't happen in the class. So one should try to follow that, in my opinion. So that's another autonomy. Which method you will follow, to what extent you will follow, what will be the combination of how many of these you will follow, not necessarily all you will follow, is your autonomy. And that's why I'm talking about that. And then the third slide on the autonomy from my side is meta university concept. I'm sure many of you have already heard about that concept. It was coined some 10-15 years back in Indian context. Jamia Millia University, JNU, and DU, Delhi University, had started something somewhere around 2010, I would say, but the initiation might have happened a little earlier. So already Meta University concept is going to be supported by CBCS, choice-based credit system. Then our ABC is a new version and a full-blown version of the flexibility which is there. And then, of course, the new degree nomenclatures will allow what we call Meta University concept. Then cooperation, collaboration is what will be needed. It will be free from many jurisdictions of degree nomenclatures and number of credits and credits earned and this and that. And then, of course, the students to other institutions and faculty from other institutions can help you really achieve what we call the meta university concept, which is there. And that is what precisely these 3 universities started together. But somehow it had run into bad weather, I would say. This concept of meta university had run into bad weather, and it did not succeed to the extent it should have. But the concept is still there. And I was myself kind of involved in this concept called virtual university concept 2010 with IIT Madras. some of us came together to do it for the MTech level, higher level education. We also failed at that time, primarily because we are ahead of time. The digitalization, the IT resources, the openness and acceptability, the new models, NEP were not there, so we didn't succeed. But virtual university concept is also going to come up now in terms of a. So this will be the autonomy which we will have. The educational institutions will be able to use this autonomy how to deliver the education. Now I come to the last 2 points. Not much to explain here. I don't know how many teachers are there, so I'll not do much. Faculty transformations, like I talked about the student transformation, the faculty transformations can be something like that. And you can possibly see the faculty will also want to pick their departments of their choice, the courses and subjects of their choice, because the poor guys sometimes don't get it. I'm sure many of you will agree with me. At least that happened to me when I started my career. And I cannot deliver it through a chosen mode. I have to be in the class only. I cannot show demonstrations like Professor Vijay will show. And then access through new methods, assessments through new methods, not easy because it's all prescribed as per the law of the UGC and keep the books for 2-3 years and so on and so forth. So those will all vanish possibly if we have the functional transformations coming and right mix of teaching and research. I'm good at research, but I'm forced to teach because otherwise I'll not be paid salary. If I'm bad at teaching, I'm still made to teach kind of a thing. So right mix can also happen. So these are what possibly the teachers would need. I'll not explain it much because teachers are anyway wise, they know. I'm just letting them know that these things are possible for them. And the teacher's role will change. I'm not, again, describing this slide. Teacher will be a coach, a mentor, facilitator, guide, enabler, co-learner, creator, designer, supporter, also innovator or co-innovator or co-entrepreneur. These are the attributes a teacher will have to have if a teacher has to be successful. Teacher cannot be a pure, plain, vanilla kind of a teacher alone today. Teacher will have to play these kind of roles, not necessarily all roles, but some of the roles you'll have to have in your fold if you want to be successful. That's another slide on the faculty, which I wanted to show. And therefore, a teacher will basically tailor the teaching learning strategy and build the capacity by being a friend, by being whatever it may be. And teacher will be an enabler in that sense. And the faculty strengthening framework, I'm sure some teachers will like this very much. Faculty should be sent abroad. In faculty abroad program, we already do it. Faculty should be sent to industry. We have assigned a new scheme called Faculty Industry Immersion Program. The faculty should also have recruitment from international domain to bring diversity. There should be dedicated research faculty, which I used to do in SRM, around 150 dedicated research faculty. Adjunct and visiting faculty from various domains, walks of life should be there. And then joint appointment with industry half the time here and half the time. So with that, you probably see faculty will also strengthen and improve. Various salient points we can discuss later if some of you wish. Now I come to the last 3 slides of mine, and that is, I hope time is there, sir. Professor Vijay, can I take three more slides and try to finish it? I hope should be all right. Okay. So is technology driving the future? I think my answer is yes, and that's why we are all here together. Technology owes its presence and success to the science, and I would say that the biggest thing in the technology domain is semiconductors, the computers, the internet, the mobile, and now the solar. Solar, of course, started 50, 60 years back, but it has become now very important. Of course, others are also important. And another thing which is becoming important, which is going everywhere, is artificial intelligence in terms of making big help and doing certain things. So these are the things. And therefore, I would say that technology is integral part of our life, whether it is your kitchen, whether it is your mobile, whether it is your automobile, everything is technology driven. And therefore, education will also see a big entry of what we call the technology. Till now, you see, semiconductors were developed for some other reason, but we use it. Computers were developed for other reasons, we use it. Internet. We have started using these technologies in education. Maybe mobile with the COVID times we have started. Otherwise, mobile was a punishable thing in the class. You all know that. And solar, of course, more not directly connected. AI, once again, I've already given you the example. But very soon you will see new technologies will emerge because of the need of the education rather than the other way around. Okay, so that is the importance of the technology. And if I'm just showing you two figures here, no explanation to any of the points. If you can understand the names, that will be wonderful. These are the new and functional teaching technologies already existing. Smart classrooms, I'm sure you have many of them here. Text to speech and vice versa is very important. If I'm hearing impaired, I should be able to see the text of it and vice versa, and it can be very handy in the examination. Biometric eye tracking, attention level or body language or assessment, how well you have learned or how you are reacting and all that can be there. Similarly, social networking, a lot of learning happens through social networking today and team, and you can make partners across the world, not only in your classroom boundaries or sections or whatever. And then, of course, easily accessible technologies. As I told you, IIT Madras example, you can learn data science from IIT Madras sitting anywhere in the world because they have the capacity. So these will be the, everything is accessible at a touch of button, and 3D printing gives you a lot of visualization, shape, creation, feeling, and all that. So that's, these are the technologies which we are already using partly. All right. My last slide in terms of detailing is the futuristic educational tools which you will possibly see. And these are, number one, AI will become very big and it will be present everywhere in terms of whether your learning speed is high, you should be given a basic level course or high level course, or you should be given more time in examination, or can you write in your mother tongue and then it will convert and using something. It can do inference making and all that it can do. Game-based learning, we never liked games inside the class. In fact, we never liked games in education. And now game-based learning is becoming very important, and we'll probably ask you to bring your PlayStations and other things in the class also sometime later, not now, but it's going to happen. Flexible LCD displays. None of you will carry a bag or a pen or a pad or a paper or any heavy books or anything, or sketchbook or whatever it may be. Only one foldable LCD. It will be like a design sheet kind of a thing. You fold it, you open it, it will open like a table. On the same thing, everything is connected through Wi-Fi or some internet connectivity is there. Every resource is available. Whatever teacher is writing on the board is available. What is from internet is available. Every book and other things which are required to be dumped is available on the screen or your desktop or whatever it may be. So all those things will be there. And then finally, augmented reality and virtual reality. I think Madam Sinha was also talking about that government of Rajasthan is doing something. Even subjects like history and all that can be taught by this thing that I can create Haldi Ghatika Yudh, I can create Akbar Ka Darbar and all that and show you what used to happen in those, how they used to react, Akbar, Birbal, or anyone for that matter. And then the learning will be much more deeper and immersive, which will be there. So those things will happen. And then wearable electronics. Electronics will not have to be carried as laptops and devices separately. They'll be wearable. Already the Google glasses and other things which are known that they can be used for displays and all that. And finally, the holographic presence. You don't want to sit here in the class. Your image can come in 3D form and you can be present before me, or I can be present before you in a holographic form. Right now in your webinars, you are in 2D form. This will be a 3D form which will be coming up very soon. So that's when the communication speeds and everything goes to the speed of light, and electronics becomes optoelectronics or optics or whatever that may be in that sense. Probably those things will happen. So these will be the futuristic technologies which are going to impact the education. I think with that, last slide maybe, and that is about the implementation of NEP. Since we're talking about NEP, who is going to do it? Okay, who should do it? I think the role is of institutions, faculty, and students primarily. Everyone should do it. It should not be left to the government. Government is shrugging its responsibility or saying that you better do it. The government is giving us autonomy, and that's why I touched upon that point. And we should do it. Is it already happening? The answer is yes from my side. It is already happening. ABC has already been announced. You should enroll and take advantage of that. CBC has been done for last 5-10 years. People have not understood. They should do more about it. 3-4 years models, credit exchanges, virtual university concept, as I was telling you, were prevailing before the NEP itself, but they were not welcomed. Now they should be welcomed. Delhi University is well known for 3-4 year models. Virtual university, I was myself involved, which was there. Like that, you can possibly see credit exchanges. A lot of IITs and top institutions are already doing it, and therefore it's already happening, in my opinion. And then what is lacking right now in this case? What is lacking is the implementation of the top model. The government has changed the name of the ministry, but has not changed the rest of the councils which are there. Like I was saying about UGC, AICT, they have not been changed. Creation of 4 distinctive pillars of support. One will look after accreditation, one will look after financing, one will look after various other specialist schemes, and all that is not there. And then, of course, the real challenge is we have not gone deep into understanding what NEP says, how much it says, how do I take advantage of that, and then only we'll probably see that we will see the implementation of NEP. So I think with that, everything comes to a conclusion from my side. You can probably read it, and that is that teaching learning process are going to change very fast because of technology. ABC and all the CBCS and all that will probably drive various things anytime, anywhere, any mode, any language, any speed, any specialization, many specializations. And then, of course, faculty's change of mindset is going to be very important. Otherwise, nothing will happen in the interactive form. Faculty is the key focal point for delivering all that. So their mindset, I must say that I changed my mindset after a long time. I was a faculty for 10, 15 years. I used to think I have to deliver the entire course to my students. And once the course is over, my responsibility is over. Now I know very well that my responsibility is not to cover the course, but to uncover the course, to make sure that the students know why this course has been taught, where it is important and how it is important, like that. And then, of course, higher degree of autonomy at all levels, which will give us more control. And then this is something which is still not happening, and a cause of worry for me is that forecasting manpower requirements, no one in the country is doing it. And even NEP has not talked about that, so that's a observation. But anyway, use of technology will be critical for achieving all important goals of NEP. This is my suggestion or my assessment. With that, thank you everyone for your patience and for your invitation. Thank you, Rajasthan Science Congress, and thank you all of you for this opportunity. All the best. Namaskar. And I'm open to questions if you have time. Otherwise, we can enjoy lunch and have questions and answers also. Thank you. When I said autonomy means I should know what are my powers, what are my positions, what risks I will take, what is required for my success, what is good for me or country or my institution or my domain. And those barriers are self-driven. Actually, in most cases, even now, I was president of Association of Indian Universities, which is representing a body of around 800 vice chancellors. And I meet many of them and they say, sir, government is not giving us autonomy. Now, I keep telling them that if they have to come and serve you the autonomy, then obviously you'll depend on someone who is serving you and you will never be autonomous. If I'm depending always on my servant or my boss to do something as a problem or give me as a solution, I'll never be an independent person. So autonomy is to make you independent and not to make independent the institutions, the vice chancellors, but all the professors, teachers, and then the students also. And so autonomy under NEP is going to trickle down to the lowest order. I've seen, I've studied in outside India, I've taught outside India, and I've seen the liberty the other students outside India enjoy. If they feel like hungry, they will tell teacher, today I'm hungry, I'm going out, and there's no problem with that. There's no stigma to that. There is no hard feeling to that. And sometimes it may happen that they may eat an apple or chip while they're in the class. They may ask you any amount of silly questions. You're supposed to answer it with patience. Here, it does not happen. The poor students are unable to. So there are a lot of inhibitions, barriers, which we have ourselves created in the name of our relationship between teacher and student. I'm not saying that get rid of all of them. Some protocols can remain, but some things should change. A student should be our friend. In most cases, a teacher who's guiding PhD should make sure
that the student he is guiding, who has worked on a new problem for 3, 4, 5 years, should be much better than the teacher himself, the guide himself or herself, and then only he qualifies to be a doctorate. Whereas in this case, in Indian case, it is not so. A teacher is always considered to be the supreme. No, that's not the case. If that is the case, new knowledge will never come up. It will be confined only by the so-called seniors or super seniors. So I think you are right. Barriers should go away. The mental ones, the physical ones, the other ones, whatever those may be, the regulatory ones, the government ones. Education should be free from most of such things. Bare minimum skeleton of rules and framework should be available. Rest should be free. Okay. I hope I have answered your question. Thank you. Yeah, sure. Please. बेटा एक बार माइक्रोफोन आ जाए या आप आगे आ जाइए. Give your name also if you wish.
Good afternoon, sir. I am from Kanoria College. My name is Lalita Das. I am from MSc Physics person. Sir, my question is कि आपने एजुकेशन सिस्टम को चेंज करने के लिए बोला और फैकल्टी सिस्टम सब कुछ चेंज करने के लिए बोला, तो सर इन चेंजेस की वजह से एम्प्लॉयमेंट सिस्टम भी चेंज होगा, तो उसमें क्या चेंजेस आएंगे?
देखिए, एम्प्लॉयमेंट सिस्टम हम गवर्न नहीं करते हैं, दैट इज गवर्न बाय इंडस्ट्री. बट व्हाट इंडस्ट्री नीड्स इज द स्टूडेंट शुड बी डायनामिक. लेट्स से द बिगेस्ट एम्प्लॉयर्स ऑफ द कंट्री, they need your graduation or some sort of a specialization, I agree. But when they test you for your communication skills, logical skills, analytical skills, problem solving skills, whatever. And so they will keep on defining what do they need. They need your design skills. They need your innovation quotient. Now, let's say that if you are, I've seen many students doing very well in the interviews, but when they are asked what is latest in your field, he will say, सर मैंने तो कभी पढ़ा ही नहीं, मेरे को ध्यान ही नहीं कि नया क्या है, बस हमें तो हमारे टीचर ने या स्कूल ने कॉलेज ने ये पढ़ाया ही नहीं. That means it gives you an indication the person is not innovative, not progressive, not trying to see something new in life. And so there are many attributes which are defined by World Economic Forum, which are defined by ABET. I'm saying US examples because they are most famous, more well known. In India, probably the new agencies must be doing it. AICTs and others are talking about them, but they are not a strong wish list. So our intention is not to give you one job which you'll do after graduation. Our intention is that you serve the society for 40, 50 years after you graduate at 20, 25. And therefore, if I were given the liberty to give you a very direct answer, my answer will be, I will deliver an ability called learnability in you rather than putting anything else. That you can learn anything, you can unlearn anything, you can relearn anything, anytime. I think that is the attribute I'd like to give to you as my student rather than anything else. Rest is your subject, your choice, how deep you want to go, how shallow you want to remain, you can remain. But some basic level we will ascertain like that. So in that sense, NEP is not defining the space of jobs. And right or wrong, rest of the world doesn't do it like what happens in India. We are all job centric. We are all only looking for jobs when we are graduating. But when you go to US, such campus placements, or in Australia or in UK, doesn't happen. They may happen in some sporadic way, slightly here and there, but not like the ones which we do as a crazy, that how many companies came, what is CTC, what is highest, what is average package, is it core company, is it IT company? I think those are misnomers, and many institutions are misusing it by providing wrong kind of jobs to begin with 1 lakh, 2 lakh, 5 lakh, 3 lakh packages, and later they are left high and dry. So my answer to you would be, develop your ability, jobs will follow you. And my take also on jobs is, jobs are not given, jobs are taken. You can take it if you have the ability. You will get it if others have ability to give you. If I'm your boss and I have an industry person in my hand, I'll employ you for 1 year and later he'll take you off. That's not good. All right. But if you have your ability, no one can take you off from the job. So that's the difference. And that's my answer for jobs. Okay.
Thank you, sir.
Thank you. I think you may have something here and there. Some might not raise it, but in the interest of time, I should put it to close. Professor Vijay is not signaling, but if you wish, I can continue. I'm very used to of microphones and the rostrums and dioceses and people sitting quietly in front of me. I'm a teacher of 37 plus 38 years now, more or less. So I can take you through whole day talking about some of these points. But do let me know if you have a valid question. I'll be happy to answer. Nahi? Okay. So I'm very happy. Thank you so much once again. Thank you.
Thank you so much for your enlightening and inspiring words, sir. Now we welcome you to the first technical session of the 8th Rajasthan Science Congress. We have amongst us Dr. P.C. Pancharia, the first invited speaker for this session. May I request Professor K.S. Sharma, Advisor, IAS Dean to the University, to welcome Dr. Pancharia. Thank you, sir. We now request. I'm so sorry. We now request Dr. Pancharia to take his seat on the dais. A scientist with Central Electronics Engineering Research Institute, Pilani, Dr. Pancharia took over as director, CSIR Central Electronics Engineering Research Institute in 2020. Professor, Academy of Scientific and Innovative Research, he has been associated with research and development activities in the field of intelligent measurement systems. He specializes in the area of electronics and intelligent systems and has made many contributions in R&D that have been successfully transferred to industries. He has published several research papers in peer-reviewed and other reputed journals and also in international conferences. Presently, he's working on development of intelligent instruments for food safety and quality in a range of products. Today, Dr. Pancharia will be talking about biomimetic systems for food safety assessments. We welcome you, sir. And we now request you to take over the session.
Thank you. Namaskar. Good afternoon to all of you. First of all, I thank organizing committee of Rajasthan Science Congress for inviting me for a talk. I respected Professor Sancheti, Professor Vijay, all the delegates, faculty of IIS, and students. In morning session, the Secretary DSP, in his address, the theme was that there are two lines: a good scientist or a good science student or a good professor of science is that who can anticipate the outcome of a process or the what science is doing. The anticipation before time, so that only human can do, nature can do. And Professor Sanchiti's talk, we have learned Education 4.0. This is a customer-oriented education program. Here, customer is a student. All the education systems or next future systems, next generation education systems, that is customer-oriented. So whenever you want, you can learn. When you want exam, exam is very difficult, and everybody has faced this issue. So I also faced that one, and now if it is coming that whenever I want, I can give exam. So on-demand exam, I think this is the best next generation education system we will be having. So friends, whenever we talk about emerging areas like artificial intelligence, IoT, Internet of Things, Industry 4.0. Now today we have learned Education 4.0, cyber security, and this is information era. So every time whenever new emerging systems are coming, the core theme behind these emerging systems are inspired from nature. It can be human or it can be anything else. So we talk about artificial intelligence. So it's not an intelligence, it's artificial intelligence. Means we have a human intelligence, which is a biological system, and we are emitting the intelligence of human into the machines. So the best creature in the world is nature. And whatever we are doing in all these emerging fields, we are imitating them. So that is why nowadays artificial intelligence, when you write a text, email, so 4 or 5 few word sentence are coming, they are suggesting you this one option you can take, this will be option. So what is there in human? When we talk about human intelligence, we have a brain. So what is there? We have neurons, how they learn it. There is a parallel processing. So in that way, we are learning. Suppose if there is a child, if we give a banana and ask them that, okay, this is apple. So next 4 or 5 years, we are doing the same thing. The child will learn banana, not the apple. So how we are learning? So how these learning techniques that can be embedded into the algorithms and finally into the computers, and computer perform the task of a human learning. So that is neural network. So in inaugural session, that Madam Mugdha Sinha was telling about the anticipation, the reasoning. If we go outside and there is a humidity and there is some clouds are there, and we can go outside and say that, okay, today there is a chance for rain. That reasoning power, what reasoning power we have in humans, the techniques called the area called fuzzy logic. That fuzzy, it can have the power of reasoning. So what again we are emitting is we are emitting the reasoning power of the humans. So ultimately, my focus of this today's talk is the biomimetic systems. So whenever we talk about artificial intelligence or human intelligence, there is a biological system. When we talk about any other nature-based algorithm or a system, all are biological systems, and all the algorithms are inspired from the biological system. The systems based on these is called biomimetic systems, because we are mimicking the biological system into the machines. Before going into the lecture, just I want to inform that I'm from Central Electronics Engineering Research Institute, so one of the CSIR laboratory located at Pilani. And in our institute, we have 3 major research areas. One on semiconductor devices, other on microwave devices, and third one is electronic systems. So I'm lucky to be part of this institute that all the electronics and systems are at one roof. So for society, we have started two new programs. One program is Vigyan Gaon Ki Or, where all the youth of villages, they can come to our institute for 2 weeks or 3 weeks. We train them for a basic electronics. Like for a village, you have motor pumps, you have motors, then you have cooler, you are how to rectify your electricity, how you make all these basic electronics. That knowledge we give for 2 to 3 weeks. And this program last 1 year we are started this, and more than thousands of students like unemployed youth, they got trained from these programs. The other skill program that we have is SILP. It's a high-end semiconductor skill. So we are the only institute having the semiconductor fabrication facility. So what we propose that why not all the graduate or postgraduate students, they can come to our institute for 2 to 3 weeks program. They can learn how to fabricate devices, semiconductor devices. We heard about transistor, diode, the chips, semiconductor chips. How we can fabricate at laboratory is a purely hands-on experience. So if IIS interested, then we can also offer this program to their students also. So student, because next era is semiconductor era, and now semiconductor fabs are coming in India. So there will be a job opportunity for the semiconductor field. So if you are aware of the semiconductor process, how devices are fabricated, then there will be a tremendous scope for jobs in semiconductor area, and how sensors are fabricated. That type of skills we can give. This is apart from our ongoing R&D research. So the biomimetic systems, these systems and how these systems can be used for estimation of quality of foods. So initially I will be discussing about what are the biochemical systems, then where we are working, what we have developed, and finally what are the products we developed out of this research. So it's a purely a customer oriented research. Means whenever we talk about advanced thing, then there should be a system in market, and it should fulfill the requirement of a customer. Our case is the customer is a society. Food customer is a society. So whatever we take food, it should be safe, it should be pure. The only two objectives are there. It should not be contaminated, and whenever you eat it, and you will not have any disease, or you don't have any side effect of the food. How these biomimetic systems can be used for food quality. So for example, if you look at the flights of the bird, so same aerodynamics you can find in our aeroplane. This is a honeycomb structure. So the wings of aircraft is like a honeycomb structure. So this wings of aircraft is inspired from honeycomb. Similarly, defense armor, they are spawned from the cell body of the turtle. The Mercedes Benz, the spider box fish. So all are biological systems. So this is an example of an electronic nose, because we have a nose, and now there is an electronic nose. So how the electronic nose work? So simply in nose, what we have a cilia, that is olfactory receiver, and then olfactory bulb. The signal goes to the bulb, and finally in the brain, we decide what smell it is. So can we immerse this electronic nose, this biological nose into electronic nose? So if we emit this, so what would be there? There will be gas sensors, there will be signal conditioning, and then signal will be transferred to the algorithms, because here the brain is pattern recognition. So it can be like a statistical pattern recognition, or it can be artificial intelligence, it can be neural network, it can be physiology, it can be like any optimization technique, like simply neural systems. We look at the neural system. So there are neurons. These neurons are connected to synapses, and finally it goes to the brain. So similarly, then the input neurons. These are well connected. There's parallel processing. How the neural systems learn. Similarly, artificial neural network is there. For human gestation, we have electronic tongue. So there are taste buds. We receive input from taste buds. How to embed this into the electronic system is like, in place of gas sensors, here we have electrodes. So from electrodes, you will get a response, and then response is again identified by the pattern recognition algorithm. So we are only focused on the electronic tongue, which we are working on all these biological systems. But for example, I'm only taking electronic tongue. So this electronic tongue is inspired from our biological tongue. And what we do usually, if you take any sweet or any bitter or any different taste of or if you look at the testers, like a tea testers or coffee testers or any food testers, they take the food and then, in simple, for example, in tea, there are more than 500 biochemicals. So identify 500 biochemicals by simple biological tongue and just telling that, okay, this is a best tea, or this is the good tea, or this is the worst tea. So that decision is taken by the biological tongue. But the biological tongue has also, there are issues. That's why we are going for artificial tongue. So electronic tongue, we have an array of electrodes. It's not a single electrode, because these are the multivariate measurement methods where you don't have a single sensor. You have multiple sensors, array of electrodes, and these array of electrodes with the sophisticated analytical techniques like pattern recognition, artificial intelligence, and we are learning the systems, and then finally telling that what is the test of the system. Why it is required? Because all foods are tested by the testers, human testers. So the human testers hedge their inherent like drawbacks, like they have some disease, like some cold and cough. So when they have cold and cough, the senses won't be there, or the output will be different from what it should be. And this is subjective measurement of it. Means like whatever I am a tester and other tester is there. So my opinion will be different from the other person. But this is human judgment error will be there. So there is an issue of repeatability also. So same samples, I may not give the same answer. So to how to avoid these, but these testers works into channels, and it is a real, it works for industry. But till date, there is no artificial testing type of it. So our focus is more focused on how to make an artificial tester. So this work is on how to taste the flavor or the liquor of the liquid, so that we can make artificial tester. So it has a number of applications. It's not a binded to the taste of the system, like pollution in water, like air quality monitoring, or wine, tea, coffee, minerals, fermentation process, and the pharmaceuticals. There are some pills which are very highly bitter pills. So human has to taste it. So there should be a system. If you give the pill to them, and then it can tell how bitter it is. The level of bitterness can be identified by a machine. Then it will be very, easy for the industry to formulate the devices, the tablets. So how it works? So these multi-sensors is a multi-dimensional, but nowadays it's like everything is multi-dimensional. Like mobile is a multi-dimensional device. Similarly, there is an array of sensors. It's not a single sensor, and these sensors are non-selective sensors. Like when you apply a signal, so every sensor will respond, but the sensitivity will be different and the dimension will be different. And then it will generate a fingerprint. So if a principle of a system, suppose this is an electrochemical system, it will generate an electrochemical signature. It's a potentiometric, then it's a potentiometric signature. If it is a spectroscopy, then it will generate a spectral fingerprint of a system. So this is a helicopter view of this. What we have done, we have multiple, it's basically electrochemical systems, where it's a basic 3 electrode systems. The working electrode is a multiple electrode, and then we are switching one by one, getting signal, and then developing the algorithm for this. So for electrochemical systems, you have to apply a voltage and you have to measure a current with a different electrode. So this is so for data analysis, there are different techniques. What we talk about artificial intelligence, it can be some statistical methods, or it can be some neural network, physiology. So what we have done, we have tested basic test solutions like sour, umami, bitter, salty, sweet, so that we can easily identify with our laboratory. Similarly, different types of juices, like we have taken different types of juices. There are 8 different types of juices we have taken and then successfully classify them. Similarly, all these cold drinks we have tested. Then different type of wines. In India, we have wine testers. So we have tested different type of wines also, 8 varieties of wine. And finally, we have developed a system for dairy, because today the milk what we drink, it can be synthetic milk. So how to test a synthetic milk or electronic tongue for detection of synthetic milk? We have developed the system. Dairy is a huge market because we are number 1 in world. India is the largest producer of milk, and we are contributing around 19 to 20% of total world milk. So these are the few big players like Amul and in the dairy, and the growth rate of milk production in India is a command. We are at a commanding position. So if you look at the dairy system, there are a number of like a cooperative society. There are 2 modes. One is private dairy, other one is cooperative society. So if you look at the Saras dairy or Amul dairy, similarly there are 183 societies are there across India. So the supply chain of milk, so there is a collection centers at villages, then there is a cold chain, means around 10-20 villages, there is one cold storage, so milk goes to cold storage, then there is again testing, and then it's loaded to dairy. All the processing is done at dairy. So at milk collection centers, there are the few equipment required there. So we have developed all these equipment to the dairy. But the problem in dairy, there are a number of issues. So the milk quality is the major concern for a society. The other issues are for dairy, So there are a lot of scope for advanced technology development in dairy. So these are the few products we have developed for dairy. So one of them is like we are offering a systems from farmer to the kitchen level. So that all the development was done at CSIR CDP. So this is a system which can detect adulteration in milk. So within a 10 seconds, earlier systems was like 40 to 45 seconds. Now it's not 20 to 25 seconds. we can identify whether milk is genuine milk or is a fake milk. So that system is, installed at the village level. So all the dairy, they can place their systems at village level. So whenever new milk sample is coming, they can taste it and they can, reject it at source. So these are same system, seed tester. That is a handheld system. These are the few, milk quality measurement systems, like what is the fat, protein, lactose. And then we have a latest system like milk supply chain monitoring system. Like at village level, you can place a, systems, and at dairy. So what happens whenever there is a adulteration in milk, and if anybody asks, so why this milk is adulterated, so dairy will always say that okay, because we are investigating the matter and we don't know what happens, and a lot of things, investigations are there. So the supply chain, we have developed a system. So at the instant when they are taking a milk from any single farmer, so the result will be at the desk of the quality manager. In that way, we can have the responsibility to the quality manager that okay, milk is not up to the purity what is required for the society. So we have developed this thing, and these are the few technologies we already transferred because we are the technology developers. So we are not supposed to manufacture systems. So we transferred to the different industries, and now the systems are in the market. Apart from this, milk, we are working on milk powder, khoa, paneer, like edible oils, ghee, honey. And so these are the areas where we are directly applying the biomimetic systems for food quality assessment. So this work we are doing, and if any student is interested to work in this, we have a center at Jaipur, and we are always welcome to come be there. So you can also learn what we are doing. So once again, I thank all the organizers to invite me for this lecture, and I'm pleased to be part of this conference. Thank you very much once again for inviting me.
Thank you so much for such an
Yeah, any
informative
questions?
talk, sir.
Yeah. If anybody has a question, then I can. Okay, thank you.
I now request all the participants to proceed to the hostel mess for lunch. We will resume with the first technical session after 30 minutes, that is 2:30. extend a warm welcome to sir. Thank you so much, sir. We now request Dr. Sharma to take his seat on the dais. Dr. Ram Swaroop Sharma is a fellow of the Indian National Science Academy, Bangalore, and fellow of the Indian National Science Academy, New Delhi. He has served as faculty in Geology Department, BHU, in his early years. He was a postdoctoral fellow of the Alexander von Humboldt Foundation and did high-pressure experimental work at Karlsruhe, Germany. Dr. Sharma has also received a fellowship award from the Royal Society London to undertake collaborative research at Leicester, England. Dr. Sharma has to his name publishing of more than 100 research publications in national and international journals. Today, he is going to deliver his talk on the topic, The Way Earth Works. We welcome you, sir. May I now request sir to take over the session.
Good afternoon, students and my learned audience. First of all, I apologize to two previous speakers, being Dr. S.K. Gupta and Pramod Kumar, for jumping the queue because of certain reasons. And with that, I begin my talk. I am a geologist, an earth scientist, a geoscientist. My subject is not very much familiar to most of the students who are studying here, because earth sciences doesn't find a place in 10+2 syllabus of the university and schools and colleges. So the talk which I have chosen today, the way the earth works, I have tried to make it as simple as possible, but not simpler, the words of Einstein. So try to follow me, because I have developed it in a very, very simple way. And it is half an hour. Don't take a strain. If you have a question, you can ask me during my talk also. Don't worry, I don't mind after that. You can interrupt me. And now I start the talk, please. The way the earth works. Most of the people know about earth from YouTube. Okay. Okay, thank you. Thank you. Okay, right. This is fun. This is fun. Okay. Oh no. Okay. And control. Fine. So most of the people who know something about earth, they know from YouTube. All information is there. But understanding is not there. Because you can get a lot of information from YouTube. But, understanding needs some more thinking. And without thinking, you can't do science. By practicing science, nothing. Many institutions in the country, private institutions, coaching institutions, they give you practice. They don't give you understanding. And because of that, our science or our scientists are not of that boldness and, what should I say, up to the mark. My reading, because I feel it so. Even after 22 years of retirement, I read 3-4 hours every day. How many people do that? I don't find any. Because to remain with the science, you have to love it. And I have that option for it. Okay, next one. The earth structure resembles that of the boiled egg. A yolk, which is the core in the earth, an albumen, which is the mantle, and then the shell, which is the crust on the earth. So this is the general structure of the earth. If you go slightly deeper, then the earth structure has 2 layers on the top. This is the continent, which is made up of crust. Below the crust is the mantle. Upper part of the mantle is here. There is a discontinuity or a different composition between the continental rock or oceanic rock. At the bottom of the ocean floor, there is also a crust. So that crust and this crust, they have different compositions and they overlie the upper mantle part. These two parts, the most uppermost part of the mantle and the crust make what we call the first layer. And lithosphere is about 100 kilometers plus minus, because crust is about 30 to 35 kilometers, and this is the oceanic crust is about 10 to 15 kilometers. And these crusts that overlie the plastic asthenosphere. So this is what we call the plate. You must know that this is plate, and plate is on the top of the asthenosphere. So Earth structure has two layers, the lithosphere, the crust and upper part, and below is the asthenosphere. Next one. Lithosphere is broken into large pieces. And these large pieces, each piece is called a tectonic plate or plate. These plates right atop the plastic asthenosphere, which I showed you. All these continents, they are made up of the crust, and the crust is made up of three types of rocks: the igneous, sedimentary, and metamorphic. All these continents, they are made up of these rocks and are separated from each other by oceans. These names of oceans, all oceans are interconnected, but for geographical and historical reasons, we have given different names. Don't worry about that. But ocean is a very important part. I will tell you this in my talk. Okay. The geological studies of rocks started in different continents using different methods by geoscientists who proposed hypotheses and theories. I must tell you here, science cannot be done without equipment. All those places which are poor in equipment, infrastructure, they can't do science. You can teach science, but encouraging the scientists to handle the data producing systems, you have to have different types of environment. Anyway, now the hypotheses and theories in science as a result of critical observation. Mind you, in science, the observation is very important. If I ask you people, how a cow walks, चार पैर है, गाय कैसे चलती है, कौन सा पैर किधर जाता है? If you have not seen it, you are poor observation. So this observation is very important in science. The critical observation. Okay, critical observation and data collection are important among the science performing methods. When you do science, you need good observation and data collection. The best example in earth science of this method is by Wegener's hypothesis, known as continental drift. This man, very critical observation. A German, by birth also Germans are very hard. I worked with that laboratory. They are stabilized. So this man, he was born in 1850 and 1930, 50 years time. He did marvelous work, and I will describe that in a language which perhaps will disturb you sometimes. This man, he was a very critical observation. What is it? He was looking at the wall map or atlas of the world in his room. So many students are having atlas or globe in their room. Important that you must have something basic you want to know science. Every day news comes up. Any city, you must look immediately. This city is observation, very important to do science. Anyway, this man was observing the world map. And he found, and he looked very simple in that understanding, as if this was attached to this one, this was attached to this one, this was attached to this one. This was an observation of this man. regular. And then what he thinks is, he observed those lines matching as if the continent once joined across the Atlantic. Wegener, then what to do next one? Wegener started experiment, and he did it. Wegener searched and found three main evidence. Geologic evidence in the layers of rock. Second, fossil evidence in the places of certain fossils are found. And then climate evidence, changing climate. So which continent was where and what rocks are there if they were together once upon a time? And he did it marvelous. He put all the evidence on the map. Hope you are. Am I fast? Okay. He put all the evidence on the map. Here. He found the rocks, very similar rocks here. He found the mountains, very similar here. He found the plant fossils here. Those midrib, plant fossils with the midrib, without midrib. He found this continent, this continent, this continent. Oh, fantastic. And he found the dinosaurs also. Dinosaurs here, here, here. How could they be there? Because they are separated by ocean. A remarkable thing of this man. And then what he did, this was in 20 years age of this. When he was in 1900, he collected evidence, and in 1912, he put the whole thing in the book form. That is what we call consensus theory by Alfred Wegener. And friends, he put this, and he made a supercontinent, which he called Pengi. And the Wegener fitted the continents like jigsaw puzzles. And in 1912, he published a book, The Origin of Continent and Ocean. These are the overlaps. But it was not the coastal area, it was the edge of the continent. Okay. Then Wegener called this continent as Pengi. Later, he shifted apart to the present position. So this is the Pengi. It's separated, continent separated in the present day today. Wegener's hypothesis called continent region. Now, this was a Pengi, separated as 180 million years, 200 million years got together, and then in later, Africa, America, this was separated, and Africa, South America got separated. Okay, so this is, as India got separated from the assembly, from the continental assembly, at 65 million years. That book was published. All geological evidence, sitting of continent and their separation. Wegener's hypothesis of continental drift was not accepted by scientific community because Wegener could not explain the cause or the sources responsible for drifting those massive continents and rocks. Okay, without in science, you don't do anything to find anything. Everything is there in nature. Right? You don't discover anything in science. You go only, keep only explanation. Why is it so? And the right part of science is explanation. That's all. That is the whole effort of understanding of science. Okay. He was adamant. He was irresistible. The temperament of, he said, why can't I find this one? What he did, in 1930, he arranged an expedition in the icy land of Greenland, the never crossed this way. Why? To measure the thickness of the ice glacier, as a possible cause of significant to move the continent. And he did it. He made it a one group will start from the west coast. This is the Arctic Circle. Find it please here. This is Arctic Circle. So one group will go from here, another group will go here, and they can will meet here by measuring by echo-sounding method. The method is the thickness of the Arctic. But what happened, friends? They both look rock continent for connection due to heavy, heavy snow. Wagner fell in a crevice. Other parts died of fire. And what happened? More evidence were collected in favor and against the conferences. National, international conferences were held at different places. Then what happened? Appeared the new science. Paleomagnetism. Old magnetism in the rock. And this was due to EMS jacket. What did it say? 5 minutes more. I will see questions. This is the Earth is supposed to doesn't have a power magnet. With this, that magnetic axis is very near to the geographic axis. Okay, the north and south they are close by. The south pole of the magnet and north pole of the geographic north, they are near together, near, not exactly. And this bar magnet or magnetism in Earth is developed because of the flow of iron core of the Earth. Not because of the magnetism, but flow of I don't know how down it's trying to go, but there are two magnets with the wire. That happens in the Earth also. So here, this is the story of the magnetism, and if you see a compass, put a compass here, you know the direction. But if you allow the compass also to go, and then this is the relationship between the tangent of inclination and tangent of latitude. So if you know the inclination, then you can tell how where was it. It's not so that could be known only by when it's a desert, it was an equator. When it was glacier, it was a sand. That's it. That was it. Anyway, okay. So they people started measuring the different lavas in different continents, and they made a graph or wandering graph of the continent. That continent was here, at this time was here, and then they started doing this one. I go quickly, and polar wandering curve was so because for North America, so it formed that 50 million years it was here, here, then it was here, and here, 100 million it was here, Asia was also here, and then people started making polar wandering curves of the different continents. Then what happened then? Paleomagnetism supported that continents did move, and continental hypothesis was revived. Hypothesis of continental improved technique came up in 1960. find out the distribution that we found in the water, and they could find out the topography of the ocean. And that's how ocean was formed. If you are the seamount, there is a ridge also, there is a great ridge, then there is a plain, there is a plains also. All these things the Americans did not, because they have the equipment to do that. So this is the ridge, center ridge all along the Atlantic. It goes like this one. So, and the ridge has its place along the front. And there is a plains also. Plains are there, the ridge is there, the faults are there. And you can see here, that is how the ridge all around, the deepest ridge. You can see all encircling the globe like a switching ball on this ball. So next one. In the ocean floor, age of the lava. What a found? Oh, make it. That's it. You see layers. Everything the bar magnetic reverse position. So great. And that was a great discovery, I must tell you. But no one knows how this magnetic poles reverse, when the process occurs, and how long it takes. This area, someone okay, these findings is in thickness and it's more or less older than 200 millimeters that is already very heavy. This is, you know, and from that, or he was, suppose this problem, I find on the ocean, this is strange transform for thickness and age of ocean floor, not older than this one, and magnetism normal river. क्या करें? He was faced with two alternatives. First, either the earth expanded because of the lava flow, or the old oceanic crust destroyed a trench at the same rate at which new crust is generated in the rich crust. जैसे आदमी मरता है, and has proposed the second alternative. This is called seafloor spreading. Paleoorganism seafloor spreading conclusively suggested movement of equal space. This is the theory of plate tectonics. It explains the changing surface of the earth and many other features. The plate tectonic theory has done for geology what the theory of evolution did for earth. So important it is. So these are the plates, they move, and that is how the whole thing goes. The ocean just goes. How is earth? Thank you.
Thank you so much, sir, for such an informative talk.
Question? Very, you can address it. Uh, magnetic field, like north pole becomes south and the south becomes north in geological time. That is imprinted, and that is imprinted and
Now, we welcome Dr. S.K. Gupta, the next speaker for this session. May I now request Professor K.S. Sharma to extend a warm welcome to the speaker. Thank you, sir. We now request sir to take his seat on the dais. Dr. Sri Krishna Gupta, scientist at Bhabha Atomic Research Center, has been associated with design, installation, commissioning, and operation of 8 accelerators at TIFR and BARC. He also developed a slow positron beam facility for material science studies and many applications for societal benefits. He has been an advisor to other national accelerator facilities in the country. A former head, Technology Transfer and Collaboration Division, BARC, Dr. Gupta has also been responsible for dissemination of DAE spin-off technologies to industries and rural areas for entrepreneurship development. Presently, he is OSD DAE Branch Secretariat and Project Director of Global Center for Nuclear Energy Partnership located in Bahadurgarh, Haryana. Today, Dr. Gupta will be delivering his talk on BAE spin-off technologies and its display and dissemination to academic institutions. We welcome you, sir, and request you to take over the session.
thank you very much for giving me this opportunity. I extend my thanks to the organizers uh, for allowing us to participate in this uh, Rajasthan Science Congress. It is a very reputed event, and now it has entered 8th in the series. So my hearty congratulations to all of the organizers. And first of all, I will apologize for changing my title. Earlier, my title was BAE spin-off technologies and its implementation and its collaborative programs with the academic institutions. This was with the idea that there will be a lot of entrepreneurs and industries will be participating. So I had put some of the slides, what are the spin-off technologies and how it can be beneficial to mankind. Of course, I will not be talking here, but all those spin-off technologies are displayed in our exhibition. So this is my humble request that all the participants uh, must visit Department of Atomic Energy stall and see how the atomic energy programs. Of course, you all know that atomic energy is associated with a lot of strategic programs, energy security to the country, and many more advanced research work for the material science, for agriculture purpose, and so on. Uh, as a process, you all know that this is a very advanced technology. Atomic energy itself is a, if you if you talk about a pyramid, technology pyramid, so atomic energy and technology related to atomic energy comes at the top of the pyramid. So it needs a broad-based knowledge, and we are fortunate that our policymakers, our forefathers, visionaries like Dr. Homi Jahangir Baba, Dr. Vikram Sarabhai, and many other scientists, they supported, they brought in scientists from different areas of expertise, and they are all under one roof, and they are now in a position to groom up people around young scientists to see that how the mandate of the technology and how the mandate of the department is fulfilled. So, okay. So, if you see the mandate, uh, research, innovation, and education. That is the first mandate. Of course, we are going ahead, and I will talk about these things today. Nuclear power and fuel cycle, I am skipping because this is not an appropriate topic for this platform. But we have got a lot of experiments, a lot of models there. So you can always visit, and somebody is interested, I can always talk about it. Healthcare, healthcare is one of the important requirement of the present days. We all know that cancer is increasing day by day due to various reasons. Definitely not because of the nuclear energy. It is, there are so many other factors: urbanization, eating habits, uh, uh, and there are many factors. Cosmic radiations coming from the cosmic also is one of the factors. So we see that a lot of healthcare is needed, and particularly for cancer awareness, cancer treatment, and remediation of other complex uh, diseases. So atomic energy being a forefront technology area leader, we are now supporting the mankind by innovating new kind of medicines, new kind of devices, new kind of approaches. So the our one leading center, that is Tata Memorial Center, which is the aided institute of Department of Atomic Energy. Now it is expanding to different parts of the country. So the responsibility of treatment against cancer is now on the DAE's shoulder, and we are trying our level best to see that Indian population is getting relieved, and there is a benefit to the society. Of course, food and agriculture, industrial applications. We all know that our Honorable Prime Minister has already committed that by 2024 we want to double the income of the farmers. So we also have the mandate that how to improve the uh, agriculture uh, income for the farmers. So, in that direction, Department of Atomic Energy in general and Bhava Atomic Research Center, Mumbai in particular, they are working on developing new kind of seeds which are resistant to diseases, having shorter long maturity time, high yield, and resistant to diseases. So all these factors leading to a better quality of seeds and better quality of equipments to do the agriculture produce. And of course, we are working on food preservation technologies, how to extend the shelf life of agriculture produce, how to delay the ripening of fruits so that these fruits can reach to the longer distances and our farmers can get better prices. So in that chapter, Department of Atomic Energy has collaborated with APEDA and NAFED and Fertilizer Corporation of India Limited, sorry, this Food Corporation of India Limited, so that the grains which gets rotten into their warehouses can be irradiated and their shelf life can be increased. So we have been working very, we are in sync with all the departments now, and there are benefits to the society. And our, as per the estimates, about 40% of the harvested food is getting wasted in due to this poor warehousing facilities. Now, with the help of these radiations, uh, we are helping the system to protect the rotting of the grains, harvested uh, agriculture produce. In the same way, mangoes, we all know what is the importance of mango, how tasty it is, and it is a king of the fruit. But our people from US, Europe, and other countries, they get a mango, but it is not the kind what we have in our country. Alfonso, then Devgarh, Ratnagiri, whatever you talk about, even this Rajkot, Kesha Ram, Langda, Dasheri, all these varieties do not go to the waste because there are some restrictions. But now, after DAE started this irradiation of mangoes, now they are permitting, and our mangoes are able to reach to the other countries across the sea, and now people get a better cost. So farmers' income is definitely getting better. And another thing is lychee. Lychee has got a shelf life of only about 5 to 6 days after harvesting. So there also we have done some value addition to the fruits, and after the processing of these fruits, you can extend the shelf life of lychee to 80 days. So this way, by extending the shelf life, you can definitely reach out to the different part of the country, different part of the globe. So it indirectly helps the farmers. So that way, farmers are also getting benefited. My request again that one can go to our stall and see. Uh, Water resources is one of the important and very, it's a big demand because most of the diseases are waterborne diseases, and there we need to help the common man. DAE has developed a lot of technologies where arsenic, fluoride, iron, uranium, chromium, and any other heavy elements, they all can be removed, and we can offer good quality drinking water, bacteria-free water, even without using electricity. So that is the beauty of our technologies, and we have committed to adopt more than 5,000 villages across the country, and we are working on it. And uh, we have approached all the state agencies to give us 5 villages from their state, so that we can do the testing of the water, and then we can adopt those villages for ensuring that they get a good quality potable water. हर घर में जल, तो जो गवर्नमेंट ऑफ इंडिया का जल शक्ति का जो प्रोग्राम्स हैं, उस प्रोग्राम में हमने अपना हाथ बटाया हुआ है और काफ़ी हद तक हमें उसकी सफलता भी मिली है. इसके आगे न्यूक्लियर सिक्योरिटी, आई डिड नॉट टॉक अबाउट इट बिकॉज आई एम इन Rajasthan, and we all know that our atomic energy explosions were done in Pokhran, first time 1974, 93, 94, 95 and all that. So this is a witness state, home state for our nuclear energy, and so many other strategic programs we have been carrying out. And now without this type of advanced technologies, we cannot compete with our enemies. So that way, now you all know that India is in a very good situation, very good, having a good capability to fight with the enemies, and we have got a very good strategic stature. So this is all about our mandate. This is something which I wanted to discuss in more detail, but since there was not many broad section of audiences, so I have briefly covered my all the mandated here. Now I will go to the sorry, direct for academic institutions. So if you see the our Department of Atomic Energy structure, organizer structure, we have 6 research and development organizations. Probably all the students knows about it. Dignitaries sitting here, they all know about it. So Bhabha Atomic Research Center at Mumbai, Indira Gandhi Center for Advanced Reactors, Kalpakkam, Raja Ramanna Center for Advanced Technology, Indore, Variable Energy Cyclotron Center at Calcutta, uh, Atomic Minerals Directorate at Hyderabad, and AMD Jaipur is a part of AMD Hyderabad. Their headquarters is in Hyderabad. And Global Center for Nuclear Energy Partnership at Bahadurgarh, Haryana. So these are the 6 research and development centers. We have 5 public sector undertakings, and there are 3 industrial facilities, service organizations. There are 11 aided institutions where Tata Institute of Fundamental Research, Tata Memorial Center, Saha Institute of Nuclear Physics, Center of Excellence for Basic Sciences, Mumbai, IOP Bhubaneswar, Harishchandra Research Institute, Allahabad, NISER, Bhubaneswar, IMSC, Chennai. So if you talk about it, all leading R&D organizations connected with science and technology, they are all supported by atomic energy. And I will straight come to what are the scientific stake, what are the programs we are collaborating, and students, particularly, what are the opportunities available to them for mega science projects, which India is a partner. India is a equal partner. So there is a very good opportunities for the students to come forward, that they should get encouraged, they should have a contact. Means now website is available, all our DAE institutions and other universities are also joined this our mega science projects. And ITER is one of the mega science projects where India and Indian industries and Indian universities are also participating. So I will not go in those details. Another mega science project is LIGO. It is a laser interferometer gravitational wave observatory. It is coming in Maharashtra at Hingoli. And this is also a very good project. A lot of opportunities, university systems and multi-institutional from DAE, like Institute of Plasma Research, Raja Ramanna Center for Advanced Technology, DCSCM, and IUCA. All these organizations are collaborating, and we have support from DST also, and these things are going very well. Now, complete construction work has been planned. Some of the service buildings are ready, boundary lines are completed, and now actual project construction work will start, and then instrumentations are being procured. Um, Models and other conceptual prototypes have already been developed in the labs at IPR and at the RRK at Indore. So the moment our building comes, actual instrumentation and machineries will be deployed. So this is the advanced stage now. Another collaborative work is our Fermi National Lab in US. See, why I am talking about all this is because centers like BRC and other high-end universities, they have all the resources available. But there are certain, we need a lot of human resources. Where from we get the human resources? So our policymakers, they have decided and they have realized it that unless we support universities, small colleges, and faculties to join the hands with them and see that good quality education is imparted to them. And in the morning half, we listened from that new education policy from Dr. Sancheti. So this is how the things are happening now. It has been realized. Of course, it is late, but nevertheless, it is there now. So now the idea is leading institutions in the country should handhold the smaller universities, faculties in the different colleges, and see that how the human resources can be developed, how the collaborative activities can be initiated, how the professors can reach to the labs and use their infrastructure. Now you must have seen across that new guidelines are there for sharing the logistics and infrastructure facilities available in all the national labs. So this is how this collaborative activities will start now, and it has already started that way. So these things, these policies will help Indian students to generate interest in science and technology and be helpful to the international mega science projects, and they can really be a backbone for advanced technologies. So I really welcome students who are interested in basic sciences, accelerator physics, or nuclear sciences, or laser science, all subjects, accelerator technologies, they should contact DAE or any other leading universities. Dr. Vijay is also part of our collaborative programs. So they can always contact us. We are well within reach, and this will be a very good opportunity for students and faculties also to participate and help growing the human resources, because now international laboratories are reaching to them India, because they have realized that human resource coming from India is really valuable, very knowledgeable, and they are really supporting and they are dependable. So we have got a lot of collaborative programs. Recently, last year, even during the COVID period, we had organized the mega science exhibition in 4 parts of the country: Mumbai, Bengaluru, Calcutta, and Delhi. And this was in a caravan mode, and 2 months these exhibits were put for 8 mega science projects to encourage students and the faculty and the universities that how these technologies and science can be propagated and how they can be helpful in participating in these mega science projects. You can see Dr. Saraswat here, Dr. Venkat Raghavan, our principal scientific advisor, Dr. Anil Kakotkar, uh, then various participation from students and various authorities. So it is very impressive to see that even it was a COVID time, but Mumbai had a footfall of about 1.3 lakh visitors, and Bangalore had about 1.4 lakh visitors. So there was a lot of interest after having such type of Vigyan Samagam exhibits. Lot of interest was generated, and now we see that this student faculties, they all get benefited, and this government of India is also feel proud that we are leading to all these mega science projects and we are equal partners. Now, coming to some of the nuclear programs in BRC, where we have in-house indigenous nuclear reactors. Again, we feel that we are
proud to have Atmanirbhar Bharat by having completely indigenous systems, like we have 100 megawatt Dhruva reactor, research reactors for producing nuclear physics experiment data. Then we also working on the production of radioisotopes using these reactors, Apsara uranium, Kamini reactor. Then there is accelerator at RRCat Indore, that is Indus 2. That is also a national facility. All universities are most welcome to participate in the experiments and generate good amount of PhDs data, and at the same time generate good quality human resource. So these are some of the things where academic institutions can participate in our indigenous programs and uh, uh, get benefited. We have added this new reactor, Apsara, which is the latest 2018. It was inaugurated. So this is a uh, low enriched uranium, and it is a water cooled type of reactor, and it is producing a lot of isotopes which are being used for medical application. And uh, forefront technologies, forefront research work also is being carried out, and it was done in a very record time. Then our Tata Institute of Fundamental Research, which is doing a lot of astrophysics work activities by using uh, radar and telescopes. So you can see that how these technologies can be useful, and it can be useful for the universities. I will not go in much details. Another example is giant meter wave radio telescope, which is situated at Pune. Again, it is a part of TIFR DAE, and it is really a challenging. And recently, it has been awarded as IAEA Center of Excellence facility. So these are the really big credential and big projects. Challenging things are happening, and we should feel proud that again here we are again saying that it is completely indigenous devices, all electronics, all mechanical systems, all data acquisition system, uh, softwares, everything is developed indigenously, and it is all homegrown thing. And lot of foreign collaborations are now started in this type of projects. Coming to last few slides now, we have deemed to be university, that is Homi Bhabha National Institute. It is a A-grade university by NAC, and uh, last year it was ranked 12th by the National Institutional Ranking Framework and termed as a rising star by Nature Index 2018. You can, though it is a very young university, you can see how our PhD numbers statistics are increasing, and this university is taking care of physics, chemistry, and all other sciences, plus medical sciences, because the Cancer Research Institute, led by our Tata Memorial Center, all students are doing their postdocs, their post graduation and postgraduate diplomas through this HBNI, and it is really beneficial. And as we know that our cancer institutes are expanding, we need cancer specialists, cancer oncologists. So these qualified doctors are coming out of HBNI, and they are serving the mankind. So uh, human resource development, we believe, atomic energy believes in hire and train approach, where we train uh, very simple and brilliant students, and they are permitted to have our experiments, our approach to our discussions with the great scientists and facilities. Then they are groomed to adopt to a newer technology area specialization, and we see that so far we have produced about 8,500 graduate science and technologies from our training school, and they have come out of the Homi National Institute. So for the young students, I have few slides. Uh, there is a opportunity for students to join atomic energy training schools. We call it orientation course in engineering. Uh, Graduates, BE, BTech, BSc engineering, 5-year integrated MTech students, even science graduates also can enter through this. There is a procedure for entry into that, and mostly it is gate and written exams. So both the channels are available, and we are having 5 centers across the country. At BRC Mumbai, it is operational since 1957. IGCAR Kalpakkam, it is from 2006. RR CAT Indore from 2000, and Nuclear Fuel Complex Hyderabad since 2001, and AMD Hyderabad since 2010. And all these 5 centers, they are dedicated for a different type of technologies and different type of expertise. Uh, we also have an opportunity for students who have qualified the gate and they have got admission into IITs and other renowned RECs, where we have an MOU with those IITs and universities that students who have secured the admission in their institute, they can still be absorbed by BRC. They will be sponsored candidates from DAE. They will get their stipend, they will get their fees paid by the department, and after 1 year coursework, they will be doing a joint project work for atomic energy in their institute. So that is the arrangement we have made. So any student uh, who wants to do an post graduation from particular IIT or from particular REC, they are free to do that, provided they are having an MOU with BRC and DAE, so that they can continue their MTech programs in their own universities. And this is how the students get benefited. And after completing their MTech program or program, they are absorbed in the Bhabha Atomic Research Center Mumbai and IGCAR Kalpakkam. I will not go in those details about how the selection process and everything goes on. So just few things. There are screening first stage, and screening can be done through gate or through written test. Uh, Stage 2 interview, and normally May and June months we conduct the interviews, and most of the students, they know about how the BRC interview takes place. So if they need any consultancy, they can always contact us. We will definitely help them out and see that they get better opportunities for taking the challenge and serve the nation and serve the science and technology. There are certain age limits and certain criteria. I will not go in those details. Uh, Another important thing is we have a center like Board of Research in Nuclear Sciences. Most of the faculties, they must be aware of it, that how to take the projects from DAE, BRC under BRNS collaborative schemes. So this is a very good opportunity that faculties can write a project. There is a committee for all type of disciplines. So they evaluate the proposals and uh, they permit funding. There is no upper limit as such, but depending on the proposal, DAE can do funding up to 50 lakhs. Even for certain cases, few crores also have been funded by DAE. And in that one can have junior research associates, JRF, SRF. There is a provision for all that. You can have equipments for your lab measurements and all. So these are the very good opportunities for faculties and the colleges and universities, that they can reach out to BRNS and get benefited from this type of facilities. Research grants are provided, as I already told you about it, how the research grants can be there. So there is an online applications. You have to just fill in data and then participate in the discussion after presentation. This research grants are approved. We have an opportunity for PhD students also. Somehow, if they are not able to join the research programs at their graduate level or at postgraduate level, still after completing their PhD, there is a K.S. Krishnan Research Associateship Fellowship is there. So those things are also available on our website, BRNS website. One can go through it. So this opportunity is available for engineering and science graduates. So uh, it's a another route to enter into atomic energy programs. There are other training programs and which are called diploma in radiological physics for medical physicists and radiological safety officer in hospitals and industries using radiation source. So this is a very good opportunity. Nearly about 25 postgraduate programs for physics we have every year. Then there is a diploma in radiation medicines, DRM, and this is about 10 surgeons are depending on the capacity of each hospital under DAE. We do the training and then there is a possibility of absorbing such doctors because they get a rich experience or after working to such places. A diploma in medical radioisotope technique, this is also there, and maybe now these numbers must have enhanced because demand is increasing and now new government policies which are suggesting that such type of expertise is must for the various type of hospitals. So to conclude, I would just say that uh, what happened? What are the opportunities for international collaboration? We have a CERN, Geneva. I think it is running in the auto mode now. ITER at France, then Hanle. We have joint programs, INO near Madurai, FAIR facility for anti-proton research, Germany, LIGO, India-based, then ILL, France. So these are the mega science programs, our ongoing collaborations with leading research institutes across the globe. And I encourage young students and faculties to join us and see that how your caliber can be utilized for the your own betterment as well as for the betterment of the country. Thank you very much. Thanks for your kind attention. I can take some questions now. I hope I have not taken more time. Just finished it. Thank you very much.
Thank you, sir, for such an informative talk.
So any questions I can give reply to from students, from faculty. So as Dr. Vijay is saying, my humble request again, please join us. Please do discuss our exhibition. Lot of actual products, working models we have brought, and our contributions to science and technology is displayed on the board. So you can interact with my colleagues, with myself, and that will be really beneficial. Thank you very much. Yes, sir. LIGO detector. Can you show some more? What is the purpose? Yeah. Actually, this LIGO project, it is a laser interferometer gravitational wave detectors. This is going to be in Hingoli near Amravati district in Maharashtra. And this project is joined with the US and there is a collaborative program. Basically, it's a large vacuum chamber and lot of mirrors and laser detectors and laser sources will be involved, and we will be able to see the effect of gravitational waves, and very sensitive system will be there. Any small vibration, any small things can be detected in the nature. And I think land acquisition is complete. Small prototypes are being made in our RR CAT center Indore and at IPR Gandhinagar, Gujarat. and very soon we are, our design building is ready. Contracts are already given, and maybe another 3 years time, our buildings will be completed. And in parallel, our in-house development work is on. We have got a sanction for the complete projects from Government of India now, and hopefully next 5 years we should see some of the activities connected to research activities. Okay, sir. Thank you very much. These are all challenging fields, and not much of technological sharing is available. So sometimes it gets, means we have to understand our own. Some of the collaborators, they definitely help us, but they don't give us the complete system. So we have to learn out of our trial and error and our past experience. So that's how things sometimes is uncertain. But definitely our scientists are capable and they are doing a wonderful job. Thank you.
Now, we welcome the last speaker for today's session, Dr. Pamposh Kumar. May I request Dr. Y.K. Vijay to welcome Dr. Kumar. Thank you, sir. I now request sir to take his seat on the dais. Dr. Pamposh Kumar, Director, Scientist F, Department of Science and Technology, New Delhi, has been working for over 2.5 decades in S&T management, policy planning, R&D, quality assurance, communication, development, and culture. He has been serving on editorial advisory boards of several journals, juries, and evaluation panels. He is currently working on new approaches and practices in theatre and cultural studies, community media, and new media based on interface ecosystems, research, and design, especially cultural and ecological interfaces. He has attended various seminars and has been a research guide to a plethora of scholars. The topic for his talk is Science Media Competencies for Risk Communication and Sustainability Reporting. We welcome you, sir. May I now request, sir, to take over the session.
Thank you very much. It's so much of a pleasure and honor. I'm thankful to Professor Vijay ji, Professor Sharma ji, organizers, learned faculty of the university, and our friends from this institution and media, scholars. In fact, you might not be expecting that when we talk science, what I would be talking, would I be really talking science, or would I be talking how to talk science? We in the National Council for Science and Technology Communication don't do science. We even don't talk science. We look at novel methods, how solution science can be connected to people. And in connecting science to people, we talk, we do, and we practice a lot of community science. Science communication is now not that what it was when World War II ended and a lot of scientists with their advanced
advanced knowledge and techniques, they were compelled to go out to the public and they had to interpret and they had to work for restoring people's faith in science. That led to a style of science communication from Western countries, but in India we have had our very fair share of looking at our masses, their problems, and the science which is in the lab, either in India or abroad, anywhere, how to make people benefit. So many experiments at my place where I am working, 2-hour projects across the country, and they've been wonderful. I just wish that even if 10% of that is shared globally, India would appear as a shining example. How can our researchers, media professionals, journalists, how successfully, effectively we have addressed people's concerns and we have prepared our scientists and our people to rise up to the challenges. In this era when the form of science communication and science journalism is changing with a rapidly evolving science media, I would like to look at you, our scholars here, over here, and our faculty also. How can you be more interested? How can you explore, find more meanings? But when you do science, and at the same time, when you represent science, wherever it is, either in media or in through alternative art forms of talking science, any medium. So I came here hoping that many of our young researchers, journalism students, media professionals would like to find out what new roles are emerging for them, what new competencies are required now, because in last decade, the canvas, how do we talk science at the same time when we do science? How is it changing? I come here with just two examples in support of the competencies I am going to talk. The science media competencies. I will just refer to two shining. I would not be very boastful, but they are really meaningful examples, latest examples, how science media has been put to service of people. When it comes to risk communication and also when it comes to reporting on sustainability. Rajasthan Science Congress has major central theme, sustainability. Okay. Our linguistics friends, probably from English department, they would be knowing, they would have heard about Umberto Eco, a celebrated name in communications theory and linguistics. He talked when he wrote and afterwards to a book. The book title is The Future of the Book. What would be the book of future? He wrote that today the concept of literacy comprises many media. So when we are talking science media, we need to be continuously introspecting and reflecting how this science literacy, this domain of science literacy is going to change forms and how science media is going to drive it further. Our science media professionals would be found in various works. CSR, journalism, risk assessors, designers, landscapers, as you can see. And the emerging sectors of science media today are why this field is changing so fast. Computational media, that is mainly data-centric gamification of science learning, ecomedia and geomedia. One speaker before, we had a wonderful presentation, and I think it is a classic case of ecomedia. I'm so happy that I could learn a lot. Environmental media, green media, and then community science media. So when we are talking about building a set of competencies of our science media professionals, in the context we are talking today risk and sustainability, it is social construction of ecological concerns. That's at the core. Then social construction of articulation, science-based articulation of our risk concerns. And beyond that, building cross-sectional platforms so that people's worldviews are changed, alternate realities are developed with them. All this would mean that there is a rise of researcher journalist, researcher reporter, or say researcher science communicator, who is also doing some science, a lot of science, and at the same time also connecting it to people. These are not the literacies for the masses I am talking here. These are the building blocks of competencies of science media. So these are literacies for scripting compelling science stories. They're overlapping. Science news aggregation or disaggregation. If there is a complex news item on science, it has to be deconstructed and decoded. Or the reverse, different news stories from different regions or from different domains, they can be aggregated and a compelling, comprehensive picture can be developed. This overlaps with science media literacy. To take our children today, how much of science would they see in any media which is in their hands? Can they distinguish that this is science media and this is some other kind of media, cultural media or some other media? But first, our science media professionals would have to develop this proficiency, ICT literacy. We so much underutilize our ICT advanced gadgets and tools, even basic tools. People science vocabulary. When we are talking science at the same time when we are doing science, how do we explain the concepts to our peers? And at the same time, how do we try to know the needs of people and try to demystify or try to explain what is happening in our labs? And that is connected with overall demystification of science. First example, when the pandemic strikes, March 2020, the challenge was when we worked in NCSTC and we had to launch a program, Yash, Year of awareness in science and health. That is a subset of national program on this communication. We had to decode what is happening across the country. So there was a very high share fear, faith, and also a little bit of science. Few glimpses I have brought from across the country. Corona goddess temples, our existing rituals repurposed to give us a sense of security, maybe false or maybe. And also there was some faith in science when medical professionals were also regarded with hope. Actual needs and wishes, when you are thinking of articulating that you have to give a scientific message and you have to connect it to the needs of people. So this is just one slide which gives you a glimpse of what we did. Bullseyes of our needs sector against the worst case scenarios in the country. Corona misinformation factories on the streets, in our households, in social media, and even inside healthcare settings. Unscientific defenses, Corona goddess temples, witchcraft, rituals repurposed, and so on. And hostility, stigma, scaremongering, resistance to well-founded health support, opposition to healthcare workers, even violence. So much of complication getting compounded every next day. I think at the top of the world, India has not seen such a massive challenge to our to this science literacy. No authentic scientific information was available in our system. Systemic burdens were there on our health sector, and there were market practices which were very predatory. Our masks, sanitizers, medicines, they were disappearing from the shelves. First line antidote, which we brought out, it is a multimedia, online, bilingual, interactive guide A to Z of the then science of Corona. It is getting updated. The beauty is that if you click the link today, it will give you today's updated information. There are so many links. It was widely received in Rajasthan, across all the districts, SRGs, DRGs, everywhere. They were equipped with the interpretation, and they took it to masses, door to door, person to person. I don't think that enough could have been done. That was much more exponentially large gap of scientific literacy, existing scientific literacy, and one which was warranted. But like the first SOS injection, it was brought up. My next example is about reporting about sustainability. Risk factors are here also, but in CSR, everywhere in lot of works, of our professional works, sustainability reporting is now critical media. We have to assure to our stakeholders that we are doing nice. We are working in tandem with the sustainability principles. This is a guide using eco-media to help our science media professionals. How can they report soundly on issues of sustainability? This is on the website ecovisionindica.org. So it is going to be launched and spread in a larger manner. The voice of the guidebook is this. Style is, there would be one tutorial and there is a news item across that. Tutorial will spell out how can we go about it? And the news item will just indicate. It will not dictate or impose. And it is for training a lot of science reporters, science media professionals. One piece I just share, it is not for this audience, but for the workshop, because reporting is misleading when it is not scientifically correct, phenomenologically and representationally truthful and psychologically congruent for the audience. This is the major risk factor when we talk science and when we do science and forget to talk science, that we don't develop the trust in public in the science which is being done and which is being reported. A way that just very much example, it is credible that the forest cover has really grown over the years, even though the rainfall had been going down. One way of stating happening. It can be restated. It is credible that the forest cover has grown compared to the baseline year so and so, 2001, even though the rainfall came down to 150 to 200 millimeters per year. That shows that when we talk our science, how much is left untalked. So the set of competencies now takes for building a mainstreaming of compelling narratives, accentuated access, retrieval, and sustained learning, and numerous alternative media forms one has to explore to use, and a real-time dynamic reporting media. The growth of such media is now more than two lenses I am sharing how to do it. On the right side is medialization of science. From our school days, you would have seen models, 3D models of heart, internal organs. That is medialization of science. If it is not articulated scientifically, if the message is not articulated, any media message, and if the balance is not decided, that in any news item, in any science narrative, how much share of articulation, scientific articulation would you like to keep, and how much stress would you like to place on simple medialization of any phenomenon? I have given a comparison kind of thing that scientific articulation uses scientific solutions lenses, genuine messaging with scientific integrity and authenticity, fairness and completeness, transparency and independence, and also attribution, heavily attributed piece of media has very high credibility. At the same time, when we talk about medialization of science, excellence in storytelling, excellence in science news and features, avoiding confrontation, respect for the audiences, sources, and subjects of coverage, and sensitivity, sensitive circumstances. Finally, data representation. The trickiest area, the trickiest thing for science media professionals, how to handle data, how to represent it statistically or how to interpret it so that right conclusions are taken home. Statistical representation very often, and it is very easy to give wrong impressions to people. So the rise of researcher reporter, I would say, that is the time two principles you need to put into practice, that is speaking diverse perspectives, but attributing everything for more accurate stories, running accuracy checks, being scientifically judicious when breaking the news. Judiciousness is required, but being scientifically judicious. I gave an example today that whether mitochondria is inside RNA or RNA is inside mitochondria. Who will decide? Who will tell people nicely? So we have to be careful and skeptical when it comes to social media, apply journalistic principles even to social media platforms, vigilant about presenting data accurately and visual journalism, and taking full responsibility of the work. With the sharing of my thoughts, I would thank you. I would like to answer if any questions are there. No questions, then I'll take your leave. Thank you.
Thank you, sir, for such an enlightening talk. With this, we have come to the end of today's technical session. And now request all to proceed towards the exhibition. Although students who have to wheel the bus facility are required to assemble in the porch. I repeat, although students who have to wheel the bus facility are required to assemble in the porch.